Web 3.0 has the potential to change the internet as we know it forever. You're still early in catching the trend right now and building your first blockchain application. Acquire the skills, get a high-paying job, or create your own Web 3.0 projects that can make you money. Hello there, and welcome to a project video where you'll build and deploy a modern, real-world Web 3.0 blockchain application. And let me tell you, I haven't been this excited for a video for a long time. With a stunning design connected to the blockchain, MetaMask pairing, interaction with smart contracts, sending Ethereum through the blockchain network, writing Solidity code, and much more, Crypt is the best Web 3.0 blockchain application that you can currently find on YouTube. You might be wondering, what are the prerequisites for building such a fantastic website? Don't worry, this course is entirely beginner-friendly. No Web 3.0, blockchain, or Solidity knowledge required. Think of this as your first real blockchain application. We're going to start easy and then move to more complex topics. I will explain every step of the way. In this video, you'll learn how to connect a regular React.js application to the blockchain and pair it to your Ethereum wallet using MetaMask. You'll also learn how to write smart contracts on the Ethereum network using the Solidity programming language. Essentially, in this single video, you'll learn how to create a full-fledged Web 3.0 application that allows users to send transactions through the blockchain. Each transaction will then be paired with a GIF, and it will be forever stored on the blockchain. To support this video, leave a like, comment, and subscribe. It shouldn't take more than a few seconds, and I really appreciate it. If this video reaches 20,000 likes, I'm recording a second Web 3.0 video. In the end, we'll also deploy the application so that you can share it with your friends, put it on your portfolio, and get a job. You can also turn this into a real Web 3.0 application that other people can use. Please allow me to give you a quick demo of the application that you're going to build in this video. As you can see, we didn't only include the Web 3.0 functionality and leave the page with no styles. You're going to build a modern, fully responsive website that's going to look like this. So, once somebody joins the application, they need to click Connect Wallet button. This is immediately going to trigger a MetaMask connection, and it's going to ask us which account do we want to connect. In this case, that's going to be account 1. So let's click Next, and let's click Connect. Instantly, you'll notice that the address of our account is right here on this nice Ethereum card. And if we open up MetaMask, you'll be able to see that our account is now connected. It might seem like we have 5 Ethereum in our wallet, but don't be fooled, we'll be doing our entire testing on the Robson test network. With that said, how do we actually send Ethereum through our application? We can do that by switching our account to account number 2, and let's copy the address of our second account. Now we can paste that address right here. We can choose the amount of Ethereum we want to send. Let's do 0.01 in this case. And in here, you can choose the keyword you want to attach to your specific transaction. This keyword is going to be saved as data in the blockchain. So in this case, let's simply write test. And you can also pass an additional piece of data, which is a message. So let's say, hello there from account 1. And finally, let's click send now. MetaMask is going to ask us if we want to send 1 Ethereum. So let's go ahead and click confirm. And then a second notification is going to appear, and this is going to be a contract interaction. So in here, we are actually interacting with our Solidity Ethereum smart contract. So let's click confirm. As you can see, our transaction is being sent as we speak, and our loading is now gone. So let's scroll down and see if our transaction is here. We also have this nice section that explains our application. And right here, we have our latest transactions. As you can see right here, each transaction is stored in the blockchain forever. We can see the address of the account that sent that Ethereum. And not only that, If you click it, it's going to open up an Ether scan and you'll be able to see that this is a real address that's sending real transactions through the blockchain. Isn't this crazy? We can also see who are we sending the Ethereum to and the amount of Ethereum that we are sending. There is also our message, and here is our GIF. In this case, I think we typed test, so this is indeed testing. And we can see the correct date and time of our transaction. You can see right there we have some other transactions that have been made through our own network. And that's it. At the bottom we have a simple footer, and that makes our entire application. The real focus is going to be to implement Web3 into our React application, make it send transactions through the blockchain, and then store those transactions and show them right inside of our application. We've got a lot to cover, so let's go ahead and get started. Before we start building out our project, let's first get the hosting and the domain name for our new site. Hostinger is my personal recommendation, and right now they're offering crazy deals, so I simply needed to show this to you. They offer a great price to quality ratio, high-speed servers, and most importantly, 24/7 chat support. Let's see what's offered with some of the most popular hosting plans, and let's grab those deals. Hostinger's plans are incredibly cheap. I mean, $1 a month for hosting for one website, and you also get a free SSL certificate. That means that you'll have HTTPS security. In my case, I'm gonna go with the premium shared hosting because it offers a few great things we'll need when building out our crypt project. It gives you a free email account, free SSL, but most importantly, it gives you a free domain name. Of course, if you still decide to get single shared hosting, you can later buy the domain name separately. All Web 3.0 applications need to be fast, reliable, and secure. That's why having a good domain name and an SSL certificate makes all the difference. Of course, improving your load times will definitely make your page stand out from the crowd. Since I've partnered with Hostinger, they decided to give you an even bigger discount. You can find the link and the discount code in the description. Enjoy! Once you visit the link in the description, let's choose a plan. I've selected Premium Shared Hosting, and here we have to choose the period of our hosting. With this crazy discount going on right now, I'll definitely choose 48 months to save the most money. And down below, you can choose your payment method, and then you can enter your coupon code. That's going to be JavaScript Mastery, all uppercased. That's going to give you an even bigger discount on your hosting package. After you purchase it, you'll be redirected to Hostinger's dashboard. I'll see you there. As you can see, I'm personally using Hostinger for my brand for all of my websites. If you've purchased premium shared hosting, then you should have this claim your free domain button right here. If you bought a single shared hosting, then you can go to domains and then purchase the domain from here. In my case, I'll click the claim domain button. Let's try something like cryptomastery.com and let's check availability. And that seems to be free. This is actually a great domain, so let's go ahead and claim it. And our domain name is being set up as we speak. And there we go. The process took about a minute and it's fully set up. What we can do right now is go back to home, and then we can set up our premium shared hosting. We can click Start Now, and as you can see, Hostinger offers immediate hosting for WordPress and WooCommerce. But in this case, we can click this button, Skip, I will start from scratch. In here, we can choose the domain name for our site. If you haven't claimed your free domain, you can do that right here. But if you have, you can choose it right here. So I'm going to go with cryptomastery.com and let's click select. Finally, we can finish the setup. The setup is being initialized, and after that is done, we'll be able to start coding out our project, and then at the end of the video, we'll deploy our website. While our hosting is setting up, I just wanted to quickly let you know that there is a GitHub repository containing the entire code for this project. So if you ever get stuck, just make sure to visit the GitHub link down in the description and compare your code with the code that's on here. That'll help solving all of your issues. While you're here, I would also appreciate it if you gave this repository a star. With that said, let's check if our hosting is fully set up. And there we go. Our website is ready. Let's go to the control panel by clicking the Manage Site button. At the end of this video, as I've mentioned, we're going to deploy our project using Hostinger's file manager. So with that said, I know you've been waiting for it. Let's dive straight into the code. As we always do on JavaScript Mastery, we're going to start from the bare beginnings, and that is creating a new folder on our desktop. Just create an empty folder and call it however you like. In this case, I'm going to call it Web 3.0. As soon as you create it, feel free to open an empty Visual Studio Code window or your code editor of choice, and then simply drag and drop the folder into it. Now let's expand our editor, and the setup process is going to be a bit different from our usual videos. We're going to create one new folder, which is going to be called Client. This is where our React application is going to be. And we're going to create another folder, which is going to be called smart_contract. As the name says, this is where our Solidity contract will go. Now that we have those two folders, we can initialize our React application. We can go to View and then Terminal. We can clear the console and then cd into Client. Now our client side is opened. Instead of using Create React App to initialize our application, in this video, we're going to use Vite. This is a new technology that I found, and it installs, builds, and starts your React applications in a few seconds. We no longer have to wait until Create React App initializes our application. So let's get started. The only thing you have to do to create your React application is scroll down and run npm init vite add latest. Of course, if you haven't used npm before, then just make sure to download and install Node. Then you'll be able to run all of the npm commands. With that said, let's go back to our terminal. And right here, we can just type npm init vite add latest. If you're running this command for the first time, the terminal is just going to ask you if you want to install Vite, so simply press enter. In my case, the project setup began instantly. For our project name, let's simply say /, because we are already in the folder we want to create our project in. Let's choose the package name, which is going to be crypt in my case, but feel free to call it however you'd like. Let's choose a framework. I'm going to go with React, and a variant is going to be simply React. And that's going to be it. Now you can simply run npm install. This process took just 9 seconds, and now we can run npm run dev. And in only 500 milliseconds, it loaded, and you can control-click localhost 3000. And our React app is initialized. I'm still not sure how I haven't heard about Vite before. For all of our styles in this project, we're going to use something called Tailwind. Tailwind allows us to build modern websites without leaving our JSX pages. It's a utility CSS framework which allows you to shape and style your designs without having to write a line of CSS. You just write these utility classes and that's it. Down below in the description, I'm going to leave the link to the installation with Create React App, but the process is the same with Vite. So let's go ahead and set up Tailwind. The only thing we'll have to do is run npm install -d, Tailwind CSS, post CSS, and auto prefixer. So let's copy it. Let's stop the terminal from running by pressing Ctrl+C and then Y. And let's simply paste npm install and install all of the necessary dependencies. Once that is done, we can also run npx tailwind css init. So right here, paste it, and that created a tailwind css config file. There we go, and also a post css config file. Now we can copy our template paths. So let's go ahead and copy this and paste it to tailwind config right here. Now we have to add the tailwind directives to our CSS. So let's simply copy this And inside of the source, index.css, we can delete all of this and simply paste Tailwind base, Tailwind components, and Tailwind utilities. Finally, we can copy this h1, go to our app.jsx, remove all of the JSX from here because we won't need that, and simply paste that h1. We can also remove the logo, the app.css, and the count right here. And of course, we are writing the most modern code, so let's convert this into an arrow function. There we go. This is our React application. Finally, to check if this works, we can open up the terminal. You can either press Ctrl tilde or go to View and then Terminal. And finally, we can run npm run dev. Control click the localhost, and there we go. If the words are bolded and underlined, that means that our React application and Tailwind with it are completely installed. Great, that was it for our front-end part. Now let's initialize all of the code that we're gonna need for our smart contract. We can stop this terminal from running by pressing Ctrl C and then Y. We can cd ... to go back into the root of our directory, and then we can cd into smart_contract. Right here, we're going to run npm init -y. This is going to initialize an empty package.json, and that's going to be the starting point of our smart contract. But of course, first we need to be able to see something to code out the functionality. So we're going to focus on our React application first, primarily the homepage part that allows us to send transactions, and then once that is done, we can go back and implement the functionality of our smart contract. With that said, let's start creating our React application. Let's start with our React application by creating a basic file and folder structure. We can do that by creating a new folder inside of the source folder called components. And then inside of there, we can start listing all of our components. The first component is going to be navbar.jsx. Inside of there, we can create a basic functional component by typing const navbar is equal to a functional component. There, we're going to simply return an h1 that's going to say navbar. And just below, we need to say export default navbar. There we go. Now we can copy this, and then we're going to paste it into every single new component. So the second component on our list is going to be footer.jsx. We can paste it here. And now we can hold the Alt key and double click all of the parts where it says navbar. With that, we can simply rename everything to footer. The third component on our list is going to be loader.jsx. This is going to be a loading spinner. So again, make sure to paste it and then hold Alt and then double click all of the words and simply rename it to the name of that component. In this case, that's loader. The third component is going to be called services.jsx. We can simply paste it and rename everything to services. The fourth component is going to be transactions.jsx. And you might be wondering, what is the difference between .js and .jsx? JSX just means that we're going to write JSX code, meaning React code, inside of that file. It doesn't make any difference. You could have used the .js extension with all of these. With that said, let's continue. I'm going to paste our component and again, rename it to transactions. And the final component on our list is called welcome.jsx. That's going to be the first part of our application, so we can simply rename everything to welcome. Now, to allow our application to import all of these components in one line, we can create one final index.js file inside of the components folder. This is going to allow us to export all of the components from a single file. So we can say export default as loader from /loader. Now we can repeat this a few more times, and we can rename this from loader to navbar, and then we need to repeat the process for every single component. So let's do footer next. Then we're going to have the welcome page. We need to have the transactions, and finally services. Now that we have all of our components, we can go into app.jsx and we can import them right here. Let's type import in curly braces, navbar, welcome, footer, services, and transactions. And all of that is coming from /components. Now inside of our app, instead of having this h1, we can create a div that's going to have a class name equal to min-h-screen. This is going to be a div with a specific width. And then inside of there, we can create another div that's going to have a class name equal to gradient-bg-welcome. And inside of there, we can put our navbar and we can also put our welcome. And just below that div, we're going to have the services, we're going to have the transactions, and finally, we're going to have our footer. With that said, our basic file and folder structure is now fully set up. This definitely took a few minutes, but now whenever we start implementing another piece of code, we can simply control click and we can start implementing that specific component. The structure is done. Now we are ready to start coding. Now, before we start implementing the code, I like to have a clean working environment. So we can hold Control and then press W a few times to close all of our currently open files. The only thing we need right now is client, source, app.jsx. We can also open up the terminal and we can cd into client and run it for one final time. So that's going to be npm run dev. Let's open it up. And as you can see, we have navbar, welcome, services, transactions, and footer. Now, this is just a blank paper with 5 different components, but soon enough, these are going to be entire sections of our front-end application. Let's start by importing some default CSS styles. We're going to code out all of the components together. But to give us a jump start on this video, I'm going to just give you a list of all of the generic styles and backgrounds and gradients. That way we won't have to write them by hand. So let's go to index.css, and right here you can paste the file that you can find in the description. It's going to be under styles and other code. There's going to be a GitHub gist containing the entire index.css file. As you can see, we're not doing any logic here. We're simply importing a specific font, setting up some default styling, and then importing all of the gradients. I'm going to give you a moment to get this index.css file, and then we can dive right in. If you've imported the file correctly, you should notice that there is a gradient on our navbar and on our welcome section. So now is the time that we start coding them out. Let's start with our navbar. So we can go to app.jsx and then simply control click the navbar component. Inside of here, we can import a few icons by saying import hi menu alt4 from react-icons/hi. And below that, we can import AI outline close. And that's going to be coming from react-icons/AI. In here, we're also going to import the logo. So we can say import logo from /images logo.png. This logo is something that we don't yet have. We don't have the images folder. So I've also prepared an entire zipped folder of all of the assets that we're going to use throughout this project. To get it, go down in the description, unzip it, and then you can paste the images folder right here inside of the client directory. Just paste it. That's going to give you an animated SVG, hello.svg, and also a logo.png. Now, if you control click images right here, you can notice it's going to lead you to the crypt logo. Let's go back to our navbar, and we can finally start writing out some JSX. Our navigation bar is going to be wrapped with an HTML5 semantic nav tag. That nav tag is going to have a class name equal to w-full flex md justify-center. And if you're not sure what some of these class names mean, just make sure to check out the Tailwind documentation. If you go to tailwindcss.com/docs, the link is also going to be in the description, you can search for every single property just right here in the search. Let's search for w-full, and you can notice that w-full simply means that the div is going to take the entire percentage of the width. And that's the situation with every single other property. For example, flex, let's check it out. This is going to set the display of our div to flex. So whenever you're not sure what some of these properties mean, just go to the docs and search for that specific name. This means that on medium devices, the justify is going to be center, and on other devices, justify is going to be between. We can also have the items in the center and set the padding or P-4. Now, it would be great if we could see the changes that we code live in the browser. So let's put our browser and the editor side by side. And there we go. I've opened up the browser side by side with the editor, and we are immediately greeted with an error. Right now, we are never actually importing React icons. And for that matter, we're not importing any single package. We can see that if we go to package.json, we only have the default installed packages. So let's go ahead and install all of the necessary dependencies that our React application is going to use. We can open up the terminal, press Ctrl C to stop it from running, and then Y. In here, we can type npm install, and let's of course install a package called react-icons. And the only other package we're going to use is called ethers. This is going to allow us to interact with the blockchain and with our smart contract. Everything else we're going to code on our own. So let's press enter and wait until these two packages are installed. And while I was speaking, they were already installed, so we can rerun our application by running npm run dev. And again, make sure that you install them and run the npm run dev inside of the client directory. Great. As you can see, now we no longer have the error, but we cannot really see anything yet in the navigation bar. So let's continue coding it. Inside of our nav, we're going to have a div, and this div is going to have a class name, where on medium devices, we can say flex-0.5 in square brackets. Then usually it's going to be flex initial, justify-center, and items-center. Inside of here, we're going to render our image. So we can create a new image tag where the source is going to be equal to logo, alternative tag is going to be logo, and we can give it a class name equal to w-32 and cursor-pointer. And there we go. Here is our crypt logo. Just below this div, we can create a UL, an unordered list, and we can give it a class name equal to text-white md flex hidden list-none flex-row justify-between items-center and finally flex-initial. Now, of course, if you save that, nothing's gonna happen because we have to add some list items. We're going to create a new component right here above this one that's going to be a simple component for our nav bar item. It's going to be a functional component and it's going to accept a few props. It's going to be title and class props like this. And the only thing it's going to do is it's simply going to return an li, a list item. That list item is going to have a class name equal to, but it's going to be a dynamic block like this, margin x-4, which means margin on horizontal axis. Then we're going to have cursor-pointer, and finally we can render out all of the class props that we pass into it. And inside of our li, we're going to simply render the title. That means that now we can call our navigation bar item right here as a component. And that's the beauty of React, reusing it. Of course, we don't simply want to have one navbar item. So let's create a new dynamic block, create an array where the first item is going to be market, The second item is going to be exchange. The third item is going to be tutorials. And for the fourth one, let's do something like wallets. And then we can call a .map method on it. Our .map is instantly going to return something, meaning that we won't have curly braces here, just regular parentheses. And in our function parameters, we're going to pass the item we're looping over, which is going to be either market, exchange, tutorials, or wallets. And we can also get the index of our specific loop. So for each iteration, we want to show the navbar item like this as a self-closing tag. And we're going to provide a key equal to item plus index to make it really unique. And the title can simply be the item. Now, if we save that, you can notice that we have market, exchange, tutorials, and wallets. Now, let's also say that people can log into our application. So we can create one final ALI that's simply going to say login. Inside of there, let's give it a class name equal to bg dash, and then in square brackets with a hash sign 2952E3. I found that color to work really good. That's a basic blue color. We can give it a padding y-2 just to give it some top and bottom padding. We can also give it padding x-7. There we go. And let's give it margin x-4. Let's make it rounded -full and also make cursor -pointer. And finally on hover, let's change the background to be 2546BD. And let's save it. There we go. So now we have that hover effect. Of course, doesn't look that good right now because we're zoomed in to 300%. But if we reset it, you can notice that this is looking like a real navigation bar. Great. Now, of course, as you've noticed when we zoom it in, this feels more like a mobile view, and this is not good for mobile devices. So let's implement the navigation bar for mobile devices. Below this UL, we can create a div, and that div is going to have a class name equal to flex and relative. We'll also have to have a state that's going to indicate whether the mobile navigation bar is currently opened or not. So we can say const toggle menu and set toggle menu. That's going to be equal to react.useState, and let's simply pass false. At the start, it's going to be closed on mobile devices. Now, inside of the div, we can open a dynamic block of code, and we're going to check if the toggle menu is currently turned on. We can go into a new line and say if it is currently turned on, meaning if part of this ternary operation. In that case, we can render the AI outline close icon as a self-closing tag, and else we can render the HI menu alt 4 also as a self-closing tag. Now we can hold the Alt key and press on both lines right here and here because most of the properties are going to be similar. Font size is going to be 28. Then we're going to have a class name equal to text-white, md colon hidden, cursor dash pointer. And we also need to provide an on click where we're going to have a callback function, and we can set the toggle menu to be equal to. If it is currently open, we want to set it to false or closed. And if it's not, we want to open it up. So let's save this, and let's also reload our page, open up the inspect element, and notice where our error is. It looks like we haven't imported React in this file, and that error is coming from here, where we're trying to use useState. Recently, with the new update of React, you no longer have to import React in JSX files. But it looks like that in most cases, you'll definitely need to import either React or just some specific hooks, like in this case, useState from React. There we go. Let's save it. And there we go. We have our navigation bar. And if you click it, it changes the state from the menu to the close icon. So now when our menu is actually toggled on, we need to be able to show it. So just below, we can open a new dynamic block and say if toggle menu and meaning that the code inside of this is going to show only when the toggle menu is set to true. We can show a UL. Inside of there, we can render an LI, and this LI is going to have a class name equal to text-xl, w-full, and margin y-2. Inside of there, we want to show the AI outline close icon that's simply going to have an on-click property with a callback function, and we simply want to set the toggle menu to be equal to false, like this. There we go. This is only if the navigation bar is opened. And then below that, we need to again loop through all the items, so we can simply copy this where we're mapping over market, exchange, tutorials, and wallets. Let's copy it and paste it just below this LI. Since this is a mobile navigation bar, we're gonna make use of that class props. So let's pass class props is equal to mi-2 for margin and text-lg. Let's save it. And there is our mobile navigation bar. Now it might be better to simply open up inspect and go to the mobile view. There we go. But now we can see both the desktop view and the mobile view. We definitely have to fix that. And I've noticed the error that I have. In here, instead of hidden, I have an extra T at the end. So if I remove it, you'll notice that our desktop navigation bar disappears. The only thing left to do is to provide the class names for our mobile navigation. So just below, right here, we're gonna have a lot of classes for our UL. So let's start by saying class names, or class name is equal to a string, and it's going to have the Z index equal to 10. It's going to be fixed. The top property is going to be set to 0, and also right property is going to be set to 2. Padding is going to be set to 3. Let's save it and see if that made any difference. Okay, now you can see that this is coming on top of our navigation bar. Then we're going to have width dash, and then in square brackets, 70 vertical width, like this. There we go. Now it appears almost in the middle. Let's also set the entire height, so height screen, like this. We can give it a shadow dash 2xl, and on medium devices, we can make it hidden. Then the list is going to be set to none because we don't want to have that list items. And let's go into the new row. It's going to be a bit easier to read and write. Let's make it flex, flex dash call, justify dash start, items dash end. There we go. Now we're starting to position it. Rounded dash MD. And we're going to add a special class, which is going to be our own gradient, blue dash glass morphism. That's going to give it that glossy glass effect. Let's make the text dash white and also animate dash slide dash in. There we go. So now this is looking more like a proper mobile navigation bar. And it looks like it's not touching the right side. So right here where we have right dash 2, let's put minus in front of it to move it to the right side. This basically means -2 on the right side. Now if we close it, that looks great. And yes, this is a proper mobile navigation bar. Later on, once we have the gradients all over the place for services and transactions, it's going to look even better because there won't be a white background behind it. But that's going to be it for our mobile navigation bar. Now let's toggle off the device toolbar, and this is how it looks like on desktop. With that said, our navigation bar is now done, and we are ready for the main part of our show, which is the welcome page, with that great Ethereum card and the ability to send transactions. To start creating our welcome page, we can control-click into the welcome component. We can start by importing a few icons by typing AI fill play circle, and that's going to be coming from react-icons/AI. Then we can also import SI Ethereum, and that's going to be coming from react-icons/SI. And finally, we can import BS info circle. and that's coming from react-icons/bs. Inside of here, we're also going to import our loader component because later on something is going to load here. So we can import that from /. That's it, because we are already in the components folder. Now we can start with the JSX part of our welcome component. We're going to have one div that's going to wrap everything right here. That div is going to have a class name equal to flex, w-full, justify-center, and items-center. This is centering the entire welcome part. Then we're going to have one more div that's going to have a class name equal to flex, md flex-row, flex-call, items-start, justify-between, md padding 20, padding y 12, and padding x 4. There we go. You can see it provided some paddings. And there is one final div inside of that div that's going to have a class name equal to flex, flex-1, justify-start, flex-call, and mr, which is margin right, 10. There we go. Now inside of there, we can create an h1. This h1 is simply going to say something like send crypto, and then we can have a br tag and say across the world. If we save it, it should be somewhere around here, but it's black, so it's not easily visible. There we go. So let's provide some class names. We can say class name is equal to text-3xl. That's going to make it a lot bigger. On smaller devices, we can say text-5xl to make it even bigger on small devices. We can make it text-white, give it a text-gradient, and finally padding y-1. There we go. This is already looking so much better. Now below that h1, we can have a padding. That padding is going to say something like explore the crypto world. Buy and sell cryptocurrencies easily on crypto. This is just some placeholder text. Again, we have to add some class names. So we can say class name is equal to text-left, margin top-5, text-white, font-light. On medium devices, width is going to be 9 divided by 12. And on all other devices, it's going to be W-11 out of 12 spaces. And we can also say the text base is going to be the size. There we go. Now we have the left part of our welcome section. Now below that p tag, we're going to have a button. That button is going to have a type equal to button. It's also going to have an on click. And on click, we want to connect to the wallet. So we're going to have a connect wallet function, which we can create right here. Const connect wallet is going to be a basic arrow function. Again, it's not going to do anything yet, but later on, we're going to implement the functionality. Now, this button is also going to have a few class names. So we can say class name is equal to flex. It's also going to be flex-row, justify-center, items-center, margin y, meaning on top and bottom 5, bg dash, and then in square brackets, hash 2952E3, that's that blue color, padding dash 3, rounded dash full, cursor dash pointer, and then on hover, we want to change the background color, bg dash, in square brackets, that's going to be hash 2546BD. And of course, to be able to see something, we have to write something inside of that button, and that's going to be connect wallet. Of course, we need to make our text wide, so let's also wrap our connect wallet in a paragraph like this. And that paragraph is going to have a class name equal to text-white, text-base, and font-semi-bold. There we go, looking better already. Now below that button, we're going to create a div that's going to serve as a grid for all of our features. So right here, we can say class name is equal to grid. On small devices, grid-calls-3, usually grid-calls-2, width-full, and margin top is 10. Now we can create a div for each specific cell. So the first div is going to have the class name equal to, and it's going to be a dynamic block like this, rounded dash TL, which stands for top left, dash 2XL. And then we also want to provide a variable, which is going to be common styles like this. This common styles is going to be just a string of common styles, but it's going to be quite long. So we're simply going to type it out by hand at the top and import it later on. So const common styles is equal to a string. And again, just so you don't have to write everything by hand and copy what I do, I'm simply going to paste the styles right here. It's going to have some minimum height, paddings, and setting up the flex containers with the borders. The link to this line is also going to be in a GitHub gist down below. And as soon as you save it, you'll notice that we have our first cell of our grid. Inside of there, we can say something like reliability. Now below that, we can create one more div that's going to have a class name equal to common styles again. So we're reusing the same styles. And in here, we can say security. Now below that, we can have one more div, which we can basically replicate from here. That div is going to say Ethereum. And instead of rounded top left, it's going to be rounded top right, or TR. There we go. Then we can duplicate that below. The bottom one can say Web 3.0 like this. This doesn't have to be uppercased. And this is going to be rounded bottom left like this. Then we can duplicate this one where it says security. There we go. Put it below. And it's simply going to say low fees. And the last one we need, we're going to duplicate the Web 3.0 and just change this to bottom right. Now we have our grid of features where we're mentioning all of the specific services that we provide. And I've almost missed it. The last cell is going to say blockchain. Now below 3 of these divs, so right here, we can create a new div. And everything inside of here is going to be the right side of our desktop welcome view, meaning our form and that nice card that you saw at the start. This here is what I'm referring to. This is the finished application, and now we're building this card component, which is looking pretty great. But that's mostly just a div with some gradients, and then we're going to implement this form just below. So let's go back and start implementing that card element. First, we have to create a few divs that are going to separate our left layout from the right layout. So let's say div with a class name is equal to flex, flex-call, flex-1, items-center, justify-start, w-full. Then we're going to have the MD, empty-0, meaning on medium devices, the margin top is going to be 0, and then usually margin top is going to be set to 10. Of course, we cannot see any differences because our div is empty. So let's create the inner div right here. That div is going to have a class name equal to padding-3, justify-end, items-start, flex-column or col, rounded-xl. Height is going to be set to 40, so H40. On small devices, the width is going to be set to 72. Usually, the width is going to be set to full. Margin Y, meaning on top and bottom, is going to be 5. We have that special class called eth-card. And finally, we have that white-glass morphism. There we go. And these are the classes coming from our initial index.css. You can notice that in here we have that gradient welcome, gradient services, as well as the white glass morphism and that Ethereum card. And don't worry, this wasn't written by hand. There are a lot of online free services that allow you to create gradients for you. With that said, now we have this great looking Ethereum card. Inside of it, we can create a new div, and this div is going to have a class name, flex justify dash between, flex dash col, w dash full, and height dash full. We're basically making it a flex container. Now inside of there, we can create a new div that's going to have a class name, flex justify dash between, and items dash start. Finally, we can have one final div that's going to be a wrapper for the icon, and that div is going to have a class name equal to w-10, height-10, rounded-full, border-2, border-white. There we go. You can immediately notice it on the right side. And it's also going to be flex, justify-center, and items-center. Inside of it, we're going to put that Ethereum icon. So we can say SI Ethereum, and we can give it a font size like this, equal to 21, and color is going to be equal to #FFF. And there we go. Now we added that Ethereum logo to the card. Now, just below this div, we can also put the BS info circle, which is another icon. It's going to have a font size equal to 17, and it's also going to have a color equal to FFF. There we go. Now below this div, we're going to have one more div. This div won't have any class names, but inside of there, we can render a paragraph. That paragraph is going to have a class name of text-white, font-light, and text-sm. Inside of there, later on, we're going to render the address of the blockchain wallet that's currently connected to our application. So right here, we can now simply say 0x and then put some random letters, ... and then close it again. This is how usual addresses look like. They are written in hexadecimal. And finally, we can duplicate this paragraph below. It's going to have text white, font is going to be semi-bold. We can also put the text to be LG and give it a margin top 1. Inside of there, we can simply say Ethereum. And for now, we can just say address here. I think that looks a bit better. There we go. Great. So now we have the top part of our form, which is this great looking card. Now we are ready to actually implement the form. And to do that, we have to go a few divs down. So that's going to be 1, 2, 3. And now right here, we're going to create one more div. So this div is going to be our form. This div is going to have a class name equal to padding-5 or p-5. On small devices, the width is going to be set to 96, w-full, flex, flex-col, justify-start, items-center, and blue-glass morphism. There we go. You can notice that blue div right there. But now we have to add some inputs inside of it. And we're going to have a lot of similar inputs, so it might simply be easier to create a new component, which is going to form our input. So right here at the top, we can create an input component, which is going to be a basic arrow function. And that input is instantly going to return some JSX code. So instead of curly braces, we can just use parentheses here, and we can create a basic HTML input tag. That input is going to have a placeholder, and a placeholder is going to be equal to placeholder. So you might be wondering, where is this placeholder variable coming from? Well, we're going to pass it through the props. So what are going to be some other things that we're going to pass through props? Well, let's try to create a basic version of our input component. It's going to look like this. It's going to be a self-closing input tag. We're going to give it a placeholder is equal to, and our first field is going to be the address to. So who are we sending the Ethereum to? Then it has to have a name equal to address to in a camel case like this. Then it has to have a type, which is going to be equal to text. And finally, it has to have a handle change, which is going to be equal to handle change. That handle change is a function that we haven't yet created. So for now, I'm simply going to put a basic callback function. And as you can see, we have our input right here. Now we know which props are we passing, so we can get all of them right here. We're gonna get the placeholder, name, type, value, and handle change. Below the placeholder, we can say type is equal to type. We can also set the step of our number input to be 0.0001 because Ethereum values are incredibly high. So even the smallest of amounts makes a huge difference. Then we need to pass in the value equal to value. And then we're also going to pass the onChange, which is going to be equal to a callback function where we are going to get an event right here. And we can call that handle change that we're passing through props and pass the name and the event like so. And finally, let's give some class names to this input. Class name is equal to, and that's going to be a string of margin y-2. Now let's save it. Right now it looks bad, so let's add a few more classes. W-full, this is going to make it extend. Rounded-small, this is going to make it rounded a bit. Padding-2 to apply some padding. Outline-none. BG-transparent, there we go. Text-white. Border-none. Text-small. White-glass morphism. And that's going to be it. Our input immediately looks so much better. And you can see how much these utility classes that Tailwind provides us make things easy for us. Now we can duplicate this input a few more times just below. That's the only reason why we created a new custom component in the first place. So 1, 2, 3. We want to have 4 of these inputs. Our second input is going to be the amount of Ethereum. So we can say amount in Ether. And that's going to be amount, which is the name of our input. And the type is going to be set to number. The handle change, we can leave empty for now. Then the third input is going to be the keyword. In parentheses, this is going to be a GIF or GIF, however you want to pronounce it. And then that's going to be the keyword name. And then our last field is going to be enter message. That's going to be the message we want to transfer over the blockchain. And the name is going to be the message. Type is going to be text. And there we go. This is already looking so much better. Below of our inputs, we're going to have one more div, but this is going to be a self-closing div. It's going to have a class name equal to h dash, and then in square brackets, 1px like this, w-full, bg-gray-400, and margin y-2. This is going to be a line just like this one. And right here, just below that, we can have the is loading state. So if it is loading, then we want to show something like this, else we want to show something else. We don't have access to this is loading variable yet, so let's simply try setting this to true. And then we're going to render out our loader like this. If we save that, you're going to notice that we also have to type something in here. So for now, let's simply put that as a div. And I think in here with dark letters, it does say a loader. Later on, we're going to implement that loader component. But now if we are not loading, so if it's false, then we want to show a button. And that button is going to have a type, which is going to be equal to button. That button is also going to have an onClick property, which is going to be handle submit. And this is going to be a function that we need to create just at the top. So right here, let's say const handle submit is a functional component right here. That button is going to say send now like this, and let's give it some class names. So class name is going to be equal to text-white. There we go, send now. W-full, margin top or empty-2, border dash, and then in square brackets, 1px. Like this, p-2, border dash, and then we have to type a color. So let's do square brackets, hash, 3d4f7c, like this. Let's make it rounded dash full. And finally, every button needs a cursor dash pointer. There we go. That is our send now button. So now let's also implement this loader component. We can do that by doing a control click. And our loader component is simply going to be a div that's going to have a class name equal to flex justify dash center, items dash center, and padding dash y3. And finally, we're going to have one inner self-closing div that's going to have a class name equal to animate dash spin, also rounded dash full, h dash 32, width dash 32, border dash b dash 2, and border dash red dash 700. Now, if we go back to welcome and set this to true, you're going to notice that nice red spinning border. Of course, later on, we're going to have the isLoading state here that's going to dynamically change as soon as we click the Send Now button. Now, let's expand our browser just a bit to see how does it look like on desktop devices. There we go. Now let's check out the finished version. And it looks like this is spanning a bit more to left and right. It's taking a bit more space. If you take a look, this is all closed down to the middle. So let's see what do we have to do to achieve this kind of look. I'm going to collapse this one more time. And to achieve this kind of look, we're going to create a custom media query. So far, we've used medium right here, but let's use something like MF, which is going to stand for full. We're going to use that MF right here. We're going to also use that MF right here. And finally, we're going to use it in one last place, which is going to be on line 66 right here where we say MD is equal to MT0. That's going to be MF. And if we zoom this out a bit, we should have 2 MDs left, and we should have 3 MFs. That way you'll know that everything is right. So now you might be wondering, what is this MF? If you went to Tailwind, they're not going to have a specific medium full or something like that media query. This is a media query that's going to be appended to Tailwind by us. More specifically, you can open up your file explorer and then go to tailwind.config.js. Inside of here, we just have the basic config, but again, in the description, there's going to be a link to a GitHub gist that's going to contain the updated tailwind.config.js. The only thing that's changing here is the font, as well as we're adding that specific screen, which is medium full, and that's going to provide it a bit more width. We're going to also add these slide in animations. So just go into the GitHub gist below, copy the Tailwind config, and paste it straight into here. And as soon as you've done that, we can now expand this and zoom it in a bit, and this is looking great. I actually preferred having the window zoomed in so that you guys can see everything so much better. With that said, let's now bring this back right here. We have our Tailwind config, and we're completely done with the layout part of our welcome component. Now we are able to write the address we want to send the Ethereum to, write the amount of Ethereum, the keyword, and the message. So now we are actually going to connect this to the blockchain, and then we're going to write a Solidity smart contract that keeps track of all of the transactions that went through the blockchain. Exciting part coming up right now. To start creating the blockchain part of our application, we can close all the files and folders right here, collapse them, and then open up the smart contract part of the page. We can also go to View, Terminal, press Ctrl C to stop it from running, and then we can cd ... to get back into the root of the directory, and then cd into smart_contract. Great. We've already set up the basic package JSON, but right now it doesn't have any dependencies. So down in the description, you'll be able to find a list of all of the dependencies that you need to install. Instead of typing them out by hand, simply find this command and press enter. This process is going to take about a minute, and as soon as it's done, we'll start creating our smart contract. To create a basic structure for our smart contract, we're going to use Hardhat. Hardhat is Ethereum development environment for professionals, and it allows you to run Solidity locally. So it's going to allow us to test our smart contract first before deploying it. There we go, our packages have been installed and we are ready to run our first command, which is npx hardhat. This is going to create a basic project structure. So let's just click enter, create a basic sample project. Let's click enter one more time because we want to create it inside of here. And finally, yes, we want to add a git ignore, so press enter one more time. You'll notice that we immediately get a few files and folders, for example, this hardhat config file right here, as well as the tests, scripts, and most importantly, contracts. We're going to explore all of these. The first thing we can do to make sure that everything is running correctly is run npx hardhat test. This command just run our test script, which then created a basic greeter Solidity contract. Of course, this was just a test. We're going to create our own contracts right away. Before we start writing the Solidity code, it's going to be a lot easier if you go to extensions and then install the Solidity extension. This is simply going to provide you some syntax highlighting, so your code is going to look better and it's going to be easier to write it. So just make sure to install it. After you've done that, we can go back into our Explorer and we can delete the greeter.sol contract. That is the demo contract created for us by Hardhat. We can delete it and we can create a new smart contract called transactions.sol, as in Solidity. Inside of here, we can start writing the code for our first ever Solidity smart contract. Solidity is a fairly new programming language used for Ethereum blockchain, and it's a combination of a few languages. The creators of Solidity got inspired by JavaScript, Java, C++, Rust, and many other languages. Therefore, not only making Solidity extremely versatile, but also making it intuitive. As we start to write code in Solidity, you're gonna notice that all of that seems similar. Maybe from Java, JavaScript, but it's definitely going to make sense as it's almost written in pure English. First, we can start by choosing the version of Solidity we want to use. In this case, I'm going to write pragma, Solidity, and then the caret sign, which is Shift and 6 on my keyboard, and then 0.8.0. And we need to write semicolons at the end. You'll also notice that we get a warning right here saying that we need a license. So right here, we can copy this, SPDX license identifier unlicensed. So simply make sure to copy it and put that as the comment above your code. That's going to make that warning go away. And now that we have our license and we've chosen the version of Solidity we want to use, we can immediately create our contract. So you can simply write contract. You can give it a name. In this case, the name is going to be the same as the name of our file, which is going to be transactions. This contract is serving a purpose of a class in object-oriented programming languages. One difference between Solidity and JavaScript is that in JavaScript, you can simply say let, and then say, for example, test is equal to 5. And then later on, you can redeclare that test to be a string of 5. In most other regular programming languages, you cannot do that because they're statically typed, meaning you have to define the type of the variable at the start. That can either be a string or a number like integer. So in this case, let's define our first variable by saying uint 256, and we can call it transaction count. This is going to be a simple number variable that's going to hold the number of our transactions. Just after that, we can create something known as an event. We have to give a name to this event, which is going to be called transfer. Think of this like a function that we're going to emit or call later on. This function is going to accept a few parameters. Each one of our transactions or transfers has to have an address from. And this address here is going to be the type, and the from is going to be a variable name. Then we also need to have the address of the receiver. So that's going to be our second parameter. Then we want to have a number, meaning uint. Again, that is just a type. And the name of the variable is going to be amount. We also need to have a string equal to message, which is just the name. We need to have another uint 256, which is going to be a timestamp. So this is going to be a number that's going to say when did we send that transfer. And finally, we can have one last string, which is going to be the keyword. This is going to form our event, which later on has to be emitted from somewhere. Now, similar to creating this event, we can also create a struct or a structure. Let's call it transfer struct. And that's going to be similar to an object, but we're not actually declaring an object here. We're just specifying what properties is this object have and of what type are they going to be. So we can say it's going to have an address and the name of that property is going to be sender. This is the type, this is the name of the property. It's also going to have another address, which is going to be receiver. It's also going to have a uint, which is going to be amount. It's going to have a string, which is going to be message. Uint 256 is going to be timestamp. And finally, a string that's going to be a keyword. Now we know what properties does our transfer or transaction needs to have. We can also define an array of different transactions because we want to store all of them. To define our array, we can call it transactions, like this, but we have to define of what type are these transactions going to be. So we can say transfer, struct, and then an array sign. This means that our transactions variable is going to be an array of transfer structures, meaning an array of objects. Hopefully, so far, everything here makes sense. Now we're going to create different functions. We're going to have one function, which is going to be called add to blockchain. Again, this is just a name that we personally chose. It's going to look like this, just like a regular JavaScript function, but we immediately get a warning saying no visibility specified. Did you intend to add public? Since this is a class, you have to define the visibility of this specific function. So we're going to say that this function is public, meaning everybody can access this function. Now we can copy this to create two other functions that we're going to use. The second function is going to be called get all transactions. This is also going to be a public function, but it's going to be public view returns. And now we need to specify what is this function going to return. And it's going to return transfer struct, meaning an array of different structures, and it's going to get it from memory. Of course, later on in here, we're going to return transactions like this. And our last function is going to be called get transaction count. And it's also going to be public, and it's also going to say view returns. In this case, we simply want to return a number. And the number we're going to return is going to be return transaction count. Remember, that's the variable we created at the start. Now, I know that this public view returns and then transfer struct and then returns a number. We don't have that in JavaScript. And that might be a blessing and a curse. Statically typed programming languages are great because they set some rules. And that way, they are defending you from yourself to create some mistakes or errors or bugs in your code. Now you know that this function needs to return the transaction count, which is a number, that get all transactions needs to return a transfer struct array, which is just an array of objects, and so on. You also know that the add to blockchain doesn't return anything. It's just doing some actions. So add to blockchain is going to be the main part of our smart contract. So what are we going to do in here? Well, first, we're going to increment the transaction count. So we can say transaction count plus equal to 1. There is one more transaction right now than there was before. And in here, the linter immediately says undeclared identifier. Looks like I called it counter at the start, but I meant to use just count. So I'm going to rename it and we no longer have an error. Okay, so now we just have a number, 1 transaction, 2, 3, 4, and so on. but we haven't actually pushed our transaction into our array of transactions. So whenever we call the add to blockchain from our React application, we're gonna pass specific parameters into it. More specifically, we're gonna pass the address payable receiver. The first parameter we're gonna pass is going to be the receiver, and that's going to be a payable address. Then the second thing we can pass is going to be the uint, which is a number, which is going to be called amount. We can also pass a string, memory, message, and this memory here, it just means that this is some specific data stored in the memory of that transaction. Whereas receiver is something that must be there because it's an address, amount also must be there, but this message is just some additional data that we're passing through that blockchain. And finally, we're gonna have one more string memory field, and that's going to be our keyword. Now we have access to all of these variables and we can do something with them. More specifically, we can call our transactions array and call a .push method on it. Yes, Solidity also has a .push method and it behaves almost in the same way as it does in JavaScript. We're going to say what do we want to push, and that is our transfer struct, as you can see right here. And the last thing we have to do is pass in all of the parameters that our transfer struct needs. Let's start with the first one, which is the sender. And we actually have that already in the object called message.sender. This is something that you immediately get whenever you call a specific function in the blockchain. It's already going to be stored there. The second thing we're going to get is going to be a receiver, and the receiver is just coming through our parameters. Then we're going to have the amount, which is also coming through params. Then we're going to have a message. We're going to have the timestamp, which is going to be equal to block.timestamp. So that's going to be the timestamp of the specific block that was being executed on the blockchain. And finally, we're going to have a keyword. This is it. We're pushing a specific transaction into the transactions array. This here is not actually transferring the amount or doing anything because we haven't yet emitted the transfer event. Right now, we're just adding this transaction to the list of all transactions, but we are not actually making the transfer. To do that, we have to emit this event. So to do that, we can say emit, transfer, and then we can pass all of the same things that we're passing right here. Let's copy them, paste them here. First we have message.sender, then we have a receiver, amount, message, block.timestamp, and the keyword. And don't forget to add a semicolon. Finally, now that we know that our transaction count is actually being updated, we can uncomment this line. So now we can actually send back the transaction count. And we also know that our transactions are being added to the list of the transactions. Make sure that you have semicolons at the end of every single line. And this is going to be it. This is our Ethereum Solidity smart contract. It's used to transfer the amount and also to store all of the transactions that come through it. Great. Now there's going to be a bit of a setup when it comes to deploying and testing this smart contract. So writing it is not the only thing you have to do. But no worries, I'm going to show you how to do everything right now. To deploy our smart contract, we can go to File Explorer and then Scripts. Inside of the scripts, you'll be able to find a sample script.js. We can rename that script to deploy.js, and we can delete most of the things from here. Let's delete all of the comments and the require at the top. Let's also remake this function as an ES6 arrow function by saying const main is equal to async arrow function like this. There we go. We also don't need these comments. We don't need those comments. And let's also turn the main into an async await function. That's going to look a bit better. So let's call const run main is going to be equal to async arrow function. If you haven't worked with async await before, don't worry, it's just a different way of writing .then and .catch methods, basically dealing with asynchronous code. Inside of here, we can create a new try and catch block. Let's indent it properly. And inside of here, we can simply call await and then call the main function. This is going to execute and deploy our contract. Once we await the main function, we also have to call the process.exit with a 0, which means that the process went successfully. Okay, let's indent that. And if we go into the catch, we can say console.error, and we're going to pass in the error and simply process.exit with a 1, which means that there was an error. And we also have to run this function run main at the start. So we're going to execute the deploy.js file. First, this line is going to be executed, which is going to call the run main function, and then that's going to call our main function, which is responsible for deploying the contract. So what do we need to change here? Well, before, the Solidity contract was called greeter, but now it's called transactions. So we can rename this with transactions with a capital T. That's going to be equal to await hre.ethers.getContractFactory and then transactions. This is like a function factory or a class that's going to generate instances of that specific contract. So just below, we're going to have one specific instance of our contract, which is going to be called transactions with a lowercase t. And that's going to be equal to await transactions with a capital T dot deploy. And we don't have to pass anything as the first parameter. We're going to await transactions dot deployed, and then we're going to say transactions with a capital T deployed to, and that's going to be transactions dot address with a lowercase t. So when we run this script, our transactions are going to be deployed, and then we're going to get the address of our smart contract deployed on the blockchain network. But for our contract to be deployed, we need to have some Ethereum on our own wallet already, because everything that you do on the Ethereum network requires something known as gas, which is small fractions of Ethereum used to make something happen. So how are we going to get our test Ethereum to fund the gas for the deployment of our contract? We can go back to our browser and more specifically to the Ropsten testnet faucet. The link is going to be down in the description. On test networks, faucets simply provide you with some test Ethereums free of charge. The only thing you have to do is enter your wallet address and the Ethereum is going to be transferred to your account. Some of these faucets run out of Ethereum from time to time, so there are a lot of them available on the internet. And since we are using the Ropsten Ethereum test network, you can simply Google for Ropsten faucet and then simply open a few of them up. If one of these faucets doesn't work, you can try the next one and so on. You can see we have this one. This one seems to be down for whatever reason. This one sends you 1 Ethereum, and this is the one that I found to work the best. Keep in mind that retrieving Ethereum through the faucet is not an instantaneous process. It can take anywhere from around 30 seconds all the way to a few hours. But again, I found this specific test network to work the best. Hopefully, this is going to allow you to get your Ethereum in no time. But to be completely sure to receive some Ethereum, definitely Google Ropsten faucet and then go ahead and enter your address in few of these. The link is going to be down in the description. Of course, in here, we have to enter our own Ethereum wallet address. So to get it, we'll have to set up our MetaMask account. Let's do that right away. To set up MetaMask, you can go to your Chrome web store or the extension store of any other browser that you use. Just make sure to search for MetaMask, although I already have it here. And MetaMask is simply an extension for accessing Ethereum-enabled distributed applications. So this is going to allow us to inject Ethereum Web 3.0 API into every website's JavaScript contacts. Essentially, it's going to let us interact with the blockchain and smart contracts. So let's go ahead and add it to Chrome and add extension. It's going to appear at the top and we can also pin it. Once you click it, you're going to see this nice fox and it's going to follow your cursor around and welcome you to MetaMask. Let's click Get Started. If you're first installing MetaMask, you most likely don't already have an account. So let's click Create a Wallet. Let's click I agree. and you have to choose your password. In this case, I'm going to use a demo password, and let's click create. Now, when working with cryptocurrencies, your password is not the main thing guarding your account. Your secret recovery phase is. You're going to be given a phrase of 12 words that are the master key to your wallet and your funds. So if this is your first time working with cryptocurrencies or wallets, make sure to watch this video first. You can pause my video right here, and then we can click next. I'm going to pause it and click next right away. And in here, you can click to reveal your secret words. This has to be secret, and you have to save these words somewhere to be able to access your account if you uninstall MetaMask. So I'm not going to reveal them here. What you can do is open up Notepad on your PC and then simply copy and paste them there. Then you'll have to click next, and in the next step, you'll have to type them out one by one. Okay, I copied my words, and you simply need to click them in the order that they were first shown to you. I'm going to do that myself here without revealing the secret recovery phase, and then we can click confirm. After you've entered your words correctly, you're going to see a congratulations screen with the tips on storing it safely. Let's click all done. There we go, we can close this, and this is our first Ethereum wallet. What you can do right now is go to the top right, and we want to show and hide test networks. Once you click that, it's going to lead you to the settings, and you want to toggle this on. Now we can scroll up, and we can change from Ethereum network to Robston test network. There we go. Now all Ethereum shown on our wallets is going to be Robston test Ethereum, not real Ethereum. What you can do right now is click on this fox on the top right, and simply click here to copy your account address. Once you do that, we can go back to the Robston test faucet and paste it right here and say, give me Robston Ethereum. There we go. It sent 0.15 Ethereum to our test wallet. Let's click MetaMask again, and let's see if it maybe arrives in about 30 seconds. For me, the process took about a minute, but again, it's going to depend from time to time, depending on how many people are currently mining Ethereum on the Robston test network. If this doesn't work for you, make sure to test out all of the other faucets available online, and also give it some time, maybe an hour or two, and then we'll be able to continue with the video. But it's crucial that you have some Ethereum available here. It doesn't have to be a lot, just 0.000 something is going to be enough, but we needed to pay the gas to deploy our smart contract. With that said, we are now ready for the next step of our video. And that next step is to go to alchemy.com. Alchemy is going to help us with the blockchain development, meaning it's going to help us deploy our blockchain smart contract. What you can do is click Get Started for free. Once you do that, you're going to have to enter your credentials and create your account. But as you can see in my case, it immediately logged me in. So after you create your account, you should see a dashboard page that looks like this. As you can see, I've already been testing with a lot of different Ethereum wallets and different networks, but I decided that Robston is the best one to test with. So now you can click the Create App button on the top right, and let's give it a name, something like Crypt. Of course, feel free to use your own name. In the description, we can say blockchain smart contract. The environment is going to be development, the chain is going to be Ethereum, and the network is going to be Robston. It's incredibly important that you choose the Robston test network for this to work. Of course, later on, you can deploy the same contract on the main Ethereum network. But for now, we're going to stay on the test network so that we don't have to pay real Ethereum gas fees. Let's click Create App. Let's click View Details for our newly created application. And now you can click View Key. In here, you're going to get an HTTP key, which you need to copy. Now we can go back to our application. More specifically, we can go to hardhat.config.js. We can delete this entire file, and for now, simply paste this here as a comment so that you don't lose it. To start creating our hardhat config, let's first require, that's going to be a string, add nomiclabs/hardhat, and then that's going to be waffle. If we Google what hardhat waffle is, you can see that it is a plugin to build smart contract tests. So that's exactly what we're going to use it for. Going back to our application, we can create a module.exports file, and in here, we're going to export our hardhat config. We first need to specify the version of Solidity that we're going to use, which is going to be 0.8.0. Then we can specify the networks we want to work on. That's going to be an object of networks, and we can call it Robston. Our Robston needs to have a URL, and this is the URL that we got from Alchemy. So right here, we can copy this comment and paste it here as a string. Then we need just one more thing, which is going to be accounts. Right here, we need to type accounts, which is going to be equal to an array, and we need to pass the address of the account that we're going to use to fund this contract. More specifically, it's not going to be an address, it's going to be MetaMask, and then right here, you need to click these three dots, account details, and then export private key. That's what we need. Once you click that, you'll need to enter your password, click confirm, and then you're gonna get a private key that you can copy and simply paste straight into here. Great, now we have our config file. We have our Solidity smart contract, and we have a script that we're gonna use to deploy that contract. Everything seems to be ready. So what do we need to do to deploy it? Let's open up the view and then terminal. Let's clear it. And let's run the command npx hardhat run scripts/deploy.js --network Robston. And let's press enter. As you can see, our contract compiled successfully, and now we are waiting for the terminal to give us the address of the deployed contract. And there we go. Transactions deployed to. And now make sure to copy this. We're gonna use this back in the client side of our application. So let's go to the client side, go to the source, and let's create a new folder called utils or utility functions. Inside of here, we can create a new file called constants.js. Inside of here, we can say export const contract address. And that's going to be equal to that address you just copied from the terminal right here. But that address was not the only thing that was generated once we run the deploy command. The other thing that was generated was in the smart contract, artifacts, contracts, transactions.sol, and then right here, transactions.json. This is called an ABI. And an ABI is the contract application binary interface. That's the standard way to interact with contracts in the Ethereum ecosystem, both from outside of the blockchain and for contract-to-contract interactions. This contains all of the information about our specific smart contract. So we need to copy this entire transactions.json, and we need to paste it into utils. More specifically, create a new file called transactions.json and just paste it right here. And then back in constants, we can import that ABI, import ABI from /transactions.json, and just alongside exporting our contract address, we also need to export const contract ABI, which is going to be equal to ABI.ABI. Now we have everything we need inside of our React application to interact with our Ethereum smart contract. And let's also check if we wasted some Ethereum gas fees for the contract deployment process. If we go back to our application, you can notice that now we have 0.1482, which means that 0028 Ethereum was wasted or spent on gas fees. But let's not worry about that at all. That's great, because now we actually have a smart contract that's going to save and store all of our transactions in the blockchain. Now that we've built the React welcome part of our site and deployed an entire Ethereum smart contract, now we are ready to connect the smart contract to our React application and actually make it send Ethereum through the blockchain network. Let's go ahead and do that right away. We're going to start by cding back into our React application with cd ... and then cd client. And then we can also run npm run dev to have our application up on localhost 3000. Now that that is done, we can close all of our files and folders, just so we have a clean working environment. And we can go to client, source, and then we can right click the source and create a new folder. That folder is going to be called context. We're going to use React Context API around our entire application that's going to only serve the purpose of connecting to the blockchain. That's going to allow us not to write our logic all across all of our components. We're only going to write it in one centralized place, and that's going to be transaction context.jsx. Inside of here, we can import React as well as use effect and also use state. And these are of course coming from React. Then we're going to import in curly braces ethers, and that's going to be coming from ethers package. Then we need to import the contract ABI as well as the contract address. And these are the things that we created just now in /utils/constants. We also need to create our React context, and we can do that by saying export const transaction context is equal to react.create context. Great. Also, since we're using MetaMask, we're getting access to the Ethereum object, which we can get by typing const in curly braces Ethereum, and that's going to be equal to window. We are basically destructuring the Ethereum object from window.ethereum. And that is one really interesting thing. If we go back to our browser, go to inspect, and then open up the console right here, and go to info, we can try typing window.ethereum. And would you look at that? There is an entire object that's going to allow us to handle our Ethereum and blockchain relation. And all of this is here only due to the fact that we installed and set up MetaMask. Okay, now we know that we have our contract ABI, contract address, Ethereum window object, and we are ready to access the blockchain. We are first going to create a special function that's going to fetch our Ethereum contract. And we can do that by saying const get Ethereum contract, and that's going to be equal to an arrow function. Inside of there, we can type const provider is equal to new ethers, and that is the package we installed previously, dot providers dot web3 provider. And then we call that as a function and pass in Ethereum window object. Now that we have our provider, we can also get the signer. Const signer is equal to provider.getSigner. And we don't have to pass any parameters. Of course, let's go ahead and console log all of these things right here inside of an object, provider, as well as signer. And we're going to also have the third thing, which is going to be const transaction contract is equal to new ethers dot contract, and then we pass in the contract address, we pass in the contract ABI right here, and we pass in the signer. These are the three ingredients that we need to fetch our contract. The contract address, remember, we have it here from when we deploy the project, then the contract ABI, which is this JSON file, and then finally the signer, which we're console logging right now, so you'll see what that is. and we can also console log the transaction contract. So once we actually call this function, we're gonna get this console log. But right now we have to create our context, because where are we going to call this? We have to have a specific place where it's going to serve a purpose. For that reason, we can create a new export const transaction provider. And that's going to be a React arrow function. And every context provider needs to get one thing from the props, and that thing is children. Every context provider also needs to return something. And this return statement is in most cases just the context, so transaction context right here, and then dot provider. That way, we're wrapping our entire React application with all of the data that's going to get passed into it. And inside of here, we have to render the children. That means that whatever we wrap inside of this transaction provider is going to be rendered, and it's going to have access to this value object. Let me show you what I mean. We're going to take this transaction provider, go into the main, and right here we can import it. Let's do so by saying import transaction provider, and that's going to be coming from /context / transaction context. The only thing we have to do is wrap our application with a so-called transaction provider. There we go. Put this here, and that's it. Now our entire application is going to have access to the data that we pass into it. And by data, I mean whatever we put in here. If I say value is equal to test, let's see if we can get this value of test somewhere else in our code. For example, in the components and then welcome. To get our data, we need to go to the top of the component and then import. That's going to be transaction context coming from /context / transaction context. And also we have to import React, and with React we have to import the use context hook, and this is of course coming from React. Now inside of our component, just at the top, we can simply say const destructure the value, and that's going to be equal to use context, and then we call it as a hook. And of course, we need to provide the name of the context we want to access. In this case, that's the transaction context. Finally, let's try to console log the value. If that works, that means that we are transferring all of the data from this file successfully to any of all of our components. Back in our application, we can see that we got test from the line 25 of our welcome.jsx file. That means that the data has been successfully transferred. Of course, we don't want to simply transfer a value of test. We want to transfer some data that's going to help us connect to the blockchain. More specifically, we're going to have a new function inside of here that's going to be called const check if wallet is connected. So check if wallet is connected is an async function like this. And inside of there, we can check if there is no Ethereum object. In that case, we can return the alert that's gonna say, please install MetaMask, because we cannot do any of this if the user hasn't installed MetaMask. Then we need to get our MetaMask connected accounts. And we can do that by saying const accounts is equal to await ethereum.request. And we need to specify an object that's going to include the method. And then in here, we can say, what do we want to request? And that's going to be eth_accounts. Now we can console log that to see if we are indeed getting something. And of course, we also need a use effect because we need to call this function. So I'm going to create a use effect right here, and we're going to call check if wallet is connected right inside of there. And it's going to happen only at the start, only at the load of our application. Let's see if we indeed do get our accounts. I reloaded the page and we can see just an empty array, meaning there are no accounts. So it might be a good idea to create a functionality for our Connect Wallet button. That way, we'll be able to click this button and connect our localhost application to MetaMask. The function for connecting our wallet is also going to be in our context. So right here, we can create a new function, const connect wallet is equal to async arrow function, and we can create a try and catch block because we need to be sure that this succeeds. Inside of the try, we again need to check if they have MetaMask installed. So we're going to add this here. Then we have to request a MetaMask account, which is going to be really similar to this line. So we can copy it right here. But this time, we're not going to check for Ethereum accounts. We're going to check for Ethereum request accounts. Request accounts with a capital A right here. That way, we're gonna get all the accounts and then the user will be able to choose to connect one. Or in this case, we can set the current account to be equal to accounts and then 0. That's going to connect that first account. Set current account is going to be a set state, and you can see that because it's starting with set, but we haven't yet created it. So at the top of our transaction provider, we can create a new use state field, and that use state field is going to be called connected account, and also set connected account, and at the start, that's going to be equal to an empty string. Great. We also have to provide some error handling, so we can console.log the error, and we can also throw new error that's going to say no Ethereum object, like that. And of course, we need to pass this function right here, connect wallet is equal to connect wallet. Of course, if both the key and the value is the same, in that case, we only need to provide the key. And now we're passing this over to all of our components. With all of the components, of course, that's also going to be coming to our welcome. So right here, we can get the connect wallet, or did we say account? Let me check. That's going to be connect wallet right here. And we can now call that function right here. Looks like we won't need this function right here because we have one in the transaction context, and we're calling it on the button. Now let's save it and see if something happens once we click that button. I'm gonna reload the page and press connect wallet. And there we go. There is a MetaMask notification asking us if we want to connect this wallet with MetaMask. And we can choose the account one and click next. Finally, let's click connect. It said connecting, and now if we reload the page, there we go. In our transaction context, we have our connected account. That's great. Right here inside of the check if wallet is connected, we can check if there is an account by saying if accounts.length. And then if there is one, we can simply set the current account to be equal to accounts and then 0. That way, at the start of every single render, we're going to have access to our account. And then later on, in here, we also want to get all of the transactions. So we're going to have a function call to get all transactions. But of course, we cannot do that yet because we don't have the part of our page where we can list them out. And we also haven't sent a single one yet, so we cannot really check that out. And then we're going to have an else part. And in here, we can simply console log no accounts found. Great. Of course, it would also be a good idea to wrap all of this in a try and catch block. So let's do that. Try and catch. The entire code that we have so far is going to go inside of the try. And then if we are inside of the catch, that means that there is no Ethereum object. So we can basically copy what we have here and paste it here. Great. So now at the start of our application, we're calling if check if wallet is connected right here, and we're setting that current account. Looks like I chose a wrong name right here. I said connected account, but this here was supposed to be current account, and that's gonna be set current account. There we go. Now we are setting it, and we can also pass it through context right here, current account. Now back in our welcome, we can also get access to the current account variable. And right here where we have our button, we can say if there is a current account, or rather if there isn't a current account, then we want to render this button. But if there is a current account, in that case, there's no need for us to render this button. So now if our account is connected, then we shouldn't be able to see this button. And that's exactly the case. We can no longer see the button, which means that our account is connected. Now we have a function for checking if a wallet is connected at the start, and also a function for connecting the account. So now might be a good idea to create that one most important function, which is going to be called const send transaction. That's going to be an async arrow function, and this is going to be where our entire logic for sending and storing transactions is going to be. We can again create a try and catch block. Inside of the catch, we're going to have this, simply console logging the error and saying there is no Ethereum object. Inside of the try, we of course have to first check if the person has MetaMask installed. And then below this, we have to get the data from the form. So in some way, we have to get the data from these item fields right here, all the way to our transaction context. How are we going to do that? Think about that for a second. Where are we going to create those states? How are we going to pass that data? The answer is we're going to create those states right here inside of our context. So right here, we can say const form data as well as the set form data, and that is equal to use state, and that's going to be an object that's going to have the address to property, which is going to be set to an empty string. It's also going to have an amount, which is going to be a string. It's going to have a keyword, which is going to be an empty string, and a message, which is again an empty string. So now that we have that form data, we also need to create a handle change. So we can say const handle change is equal to a function. All handle change functions that interact with inputs accept the event, the keyboard event, the key press as the event, and also we're going to pass in a name. This handle change is dynamically going to update the form data by saying set form data is equal to. Now, whenever you're updating the new state using the old state, you have to provide a callback function in the state where as the first parameter, React gives you prev state. And we're going to instantly return an object, and you can do that by first using parentheses and then writing an object. And that object is going to have the previous state spread like this, and we can update dynamically name to include the e.target.value. This here is nothing blockchain related, but it's definitely a hard to understand function. This requires some a bit more advanced React knowledge, so if this doesn't make a lot of sense, try setting up your own small React application where you're just gonna have the form with a few inputs and then see how the data changes or how the state changes once you type into those inputs with this handle change function. There isn't really an easy way to understand this rather than trying everything yourself on a real project. With that said, we have our form data, set form data, and also the handle change function. So let's go ahead and pass those to our context object. So right here, we can pass the form data as well as the set form data and also the handle change. Now back in our welcome, we can accept all of these from the context. That's going to be form data, set form data, as well as the handle change. So now if we scroll down right here, instead of having an empty callback function in the handle change, we can delete that. Again, I held Alt and then double clicked. And in here, we can simply use the handle change function that's going to update these inputs dynamically depending on the name of that specific input. So it's really important that the names exactly match what you have in the state right here. With that said, let's see where do we have to use our set form data or anything else. We have our handle submit here. So if we click it, we have to implement that handle submit function. And right here, we can destructure all of the properties from the form data by saying const in curly braces address to amount keyword and message is equal to form data. We simply destructured these properties. Then below, we can call e.preventDefault. Usually, when you submit a form, the page reloads. But in React applications, we want to prevent that from happening, and that's why we're calling this function. Then we have to check if the user has filled in the fields, so we can say if no address to, or if there is no amount, or if there is no keyword, or if there is no message. In that case, we simply want to leave this function and not submit anything. So we're going to simply return nothing. Else, if the user successfully filled in all the fields, we can call the send transaction function like this. We've created that send transaction function, which is right here, but we haven't passed it through props. So we can do that right away, right here, send transaction, and we can get it right here instead of set form data because we're not using that. So make sure to get the send transaction right here so that we can call it at the end. Now we've created that circle. We've created the state variables here, passed them through the context value right here into the welcome. The welcome is dealing with some data, and then it's calling the send transaction button, which is then triggering this function where we're gonna get the data from the form. I know this might be a bit hard if you don't have a lot of experience with React, but keep practicing with state, inputs, and context, and I'm sure you're gonna get the hang of it. So now we can destructure the values the same way we did in the welcome. We can even copy that line right here and paste it here. Now we have access to the form data variables. We also need to get our Ethereum contract. And remember, that is the function we created right here, and we haven't called it before. So what we can do is we can call it right inside of the send transaction. That's going to be get Ethereum contract. At the start, it's not going to do anything besides simply console logging the values. So let's see, what is it going to console log? Looks like we have a typo. So let me quickly go here and check where that typo is coming from. I'm missing a curly brace right here, but after I add it, that's looking good. And now we of course have to click our send now button. So let me type test here. Let's send 0.0001. By the way, you can use these arrows here. For the keyword, looks like I have a typo there. We can type test, and we can type test right here and click send. When we do that, obviously we've got an error saying E is not defined. To fix that, we can go to our welcome and simply get the event from the parameters. I simply forgot about that, but now that shouldn't be an issue anymore. Going back, we can now clear the console by pressing this icon right here, and we can click send now one more time. And there we go. We got an object with the provider. I'm going to make this a bit bigger for you. Provider is going to be Web3 provider with a lot of different properties that we can choose from. Then we have the signer as well. And finally, we have the transaction contract, which is the most important part right here. And take a look. This transaction contract is not just any contract. This is our transaction contract, containing the function add to blockchain, get all transactions, as well as the get transaction count. If you remember correctly, these are the exact functions that we have created inside of our Solidity contract. That means that now we can go to our transaction contract, And instead of console logging all of these values, we can simply return the transaction contract. Now we can go back to our send transaction, and instead of simply calling it, we can say const transaction contract is equal to get Ethereum transaction contract. Now we'll be able to use this variable to call all of our contract related functions. Great, we're doing a lot of stuff now, and I hope it's all coming into place. With just a few more lines, we'll be able to send our first transaction through the blockchain. Now that we have all the data we need, let's send some Ethereum. We can say await Ethereum dot request, and it's going to accept an object with all of the options. The first option is going to be a method, which is going to be eth underscore send transaction, like this. And then we have to pass some params. Params is going to be an array with an object inside of it. And it's going to have a from property, and this is going to be the current account. Remember, that's what we stored straight inside of our state. Then it's also going to accept a to address. And where can we find that? Well, look, we're accessing it from the form data. So right here, we can say address to. Then this is going to be a weird one, but we have to choose the amount of gas we want our transaction to take or spend. And all of the values that you use in the Ethereum network are written in hexadecimal or hex. So we're gonna do something like 0x5208, and this has to be in a string. Now, if you cannot immediately transfer this to decimal, let's take this value and Google something like hex to decimal. Go to the first link and paste it here and click convert. This is going to take 21,000, but it's not going to be 21,000 ether. It's going to be 21,000 gwei, and that's a subunit of ether. So if we type 21,000 here, you're gonna notice that that is actually 0.000021 Ethereum. So we have to write everything in hexadecimal values that are then converted to gwei, and then that's behind the scenes actually just ether, but gwei is a subunit of ether, like a cent is to American dollar. So now we know that this is 21,000 gwei, and we also have to choose the value we want to pass. So the value is going to be the amount, right? The amount we are sending right from the form data. But that's not the case. If you think about it, the amount is going to be something like 0.001 or whatever we choose on our form. But this here is a decimal number. So we have to find a way to convert this into gwei or hexadecimal. And we can do that by saying const parsed amount is equal to ethers.utils.parse ether. And then in there, we can pass in the amount. The ethers package provides us with utility functions that we can call. And one of those utility functions is called parse ether, which just parses the decimal amount into gwei hexadecimal amount. So instead of passing the amount, we're gonna pass in the parsed amount, but we also have to do dot underscore hex like this. And that's going to be it for our Ethereum transaction. But this is only sending Ethereum from one address to another. We also have to provide the part where we call the add to blockchain function so that we store the transaction that just happened. So let's do that right below this. To store our transaction, we can call the transaction contract dot add to blockchain. As I've mentioned, that's our own function that we've created on this transaction contract. Great. So what does our add to blockchain function need? It needs an address, the amount, the message, and the keyword. So let's take these values and put them into here. The address is going to be address to. Then we want to pass the parsed amount. We want to pass the message. And finally, we want to pass the keyword. And we can get a transaction hash, which is a specific transaction ID. So we can say transaction hash is equal to await transaction contract. This is an asynchronous action, and it definitely takes some time for the transaction to go through. So we need to add a loading state. Right here at the top, we can create a new use state field, which is going to be called is loading. And then at the start, it's going to be set to false. Then we can scroll down, and right here below our transaction hash, we can say set is loading, and we're going to set it to true. Below our set is loading, we can console log and say in a template string loading, and then dynamically transaction hash, and then dot hash. Finally, we can call the await transaction hash dot wait. This is going to wait for the transaction to be finished. Of course, with one A here, I had a typo. Now, after that is done, we can call these two lines again, but we're gonna set the loading to be false, and we're gonna say success. After that is done, we can also get the const transaction, and that's going to be transaction count, which is going to be equal to await transaction contract dot get transaction count. And once we get the transaction count, we can store it in the state. So at the top, we can create one new state, use state, and that's going to be transaction count, and set transaction count at the start is going to be equal to 0. But in this case, the 0 might not be the best way to set up our transaction count, because it's going to get reset every time that we reload our browser. But we're going to store our transaction count into local storage. So right here, we can say local storage dot get item, and then that's going to be transaction count. Later on, we're going to store it there so we can always keep track of the current transaction count. Now we have this set transaction count, and just below, we can call set transaction count, and we can pass in our transaction count, then dot to number, like this. Great. And believe it or not, that's going to be it for our send transaction. If we've coded everything out correctly, we should be able to send Ether through the Ethereum network. Back inside of our browser, we can open up MetaMask and we can create a new account, because we need to have a different address that we're going to send the money to. So let's click account here, and let's click create account. We can call it account 2 or whatever you prefer, and let's click create. Now we are on the account 2, and let's copy the address to clipboard. We can paste it here under address 2. Let's send 0.0005. The keyword can be something like test, and the message can also be test. Let's open up our inspect element, go to console, and let's click send. First MetaMask notification appeared, sending ETH 0.0005. That is correct. And we're going to pay a bit extra for the fees, but that's completely okay. Let's click confirm. And then the second MetaMask notification is going to appear, and it's going to say contract interaction. So we're going to pay a bit in fees, and this is going to store our transaction on the blockchain. Let's click confirm. There we go. Our hash is loading, and this process usually takes about half a minute, but again, it depends on a lot of factors, so it might take a bit longer for you. And there we go. I've gotten success right here. Now, let's close this, and let's open up our MetaMask. On our account 2, we now have 0.005 Ethereum. Isn't that crazy? And if we go back to our account 1, we're definitely missing 0.0005 here. So, are you sharing the enthusiasm with me? Even before creating this video, blockchain-related technologies and cryptocurrencies were incredibly interesting to me. We just send Ethereum through the blockchain from one address to another. The second address could be anywhere in the world, and we just sent something that holds real value potentially all across the world in about 30 seconds. Isn't that crazy? Of course, we can go back to account 1 and then we can open up our contract interactions. Right here, you can click it, go to transaction data, and then go to send right here, open activity log, and then click transaction confirmed. This is going to open up the Ropsten test network, and as you can see, we have our transaction hash, the status, block confirmations, and the value of Ethereum sent. We can also see from which account to which account was this sent. So let's go to our account 1, and you can notice that now we have a few interactions here. The first one was the contract creation, and we have 2 outs, one for sending and one for storing. You can also see the current balance right here. Once again, I hope you're sharing my enthusiasm about this because this is definitely a revolutionary technology. With that said, we can now focus on finishing up the rest of JSX part, which is the services, transactions, and the footer. Once we have those parts, then we'll be able to retrieve all of the stored transactions and then show them just below. So now we're going to move just a bit away from all of that blockchain functionality and focus on writing pure JSX using React and Tailwind. But we're going to be back to blockchain in no time. Let's start with the services section. Let's go to File Explorer and then Services. Inside of here, we're going to import a few icons. The first one is BS Shield Fill Check. And this is coming from react-icons/BS. The second icon on our list is import BI search alt. And this is coming from react-icons/BI. And the last icon on our list is import RI heart to fill. And that's from react-icons/RI. Now for our services, let's simply create a div, and this div is going to have a class name equal to flex width-full justify-center items-center and gradient-bg-services. Now we can save that, and we can put our browser and editor side by side so that we can see the changes we make. There we go. Now inside of this div, we're going to create one more div, and that div is going to have a class name equal to flex mf flex-row flex-column items-center justify-between mdp-20 as in padding 20 and padding y, meaning on top and bottom, is going to be 12, and padding on x-axis is going to be 4. As soon as we save that, you're going to notice that we have a bit more padding right here. Now let's create one final div inside of which the content will go. So right here, we can say class name is equal to flex-1, flex-call, justify-start, and then items-start. Inside of there, we can finally create an H1 element right here. And let's say something like services that we, and then inside of a new row, we can say something like BR, as in break tag to provide some space, and then say continue to improve, like this. If we save that, we're going to notice that it's right here, but it is dark. So let's provide some class names. Class name is equal to text-white. There we go. Now let's also make it larger by saying text 3XL. On small devices, we can make it even larger by saying text 5XL. There we go. And finally, let's give it padding Y 2 and text-gradient. There we go. Services that we continue to improve. Now, just below this div, we're going to have one more div, and this is going to be for our services cards. So right here, let's give it a class name. That's going to be flex-1, flex-call, justify-start, and items-center. There we go. Now we have this on the left side, and right here, we're gonna have our services cards. Since we're gonna reuse our service card 3 times, and it's going to be the same every time, but the only things that are going to change is going to be the title, subtitle, icon, and color. For that reason, we can create a new component that we're gonna reuse. And we're gonna call that component const service card. And that's gonna be equal to, like this, to an arrow function component with an instant return. Each service card can have a div with a class name equal to flex, flex-row, justify-start, items-center, white-glass morphism, padding-3, margin-2, cursor-pointer, and then on hover, shadow-XL. Great. Now, just so we can see the changes we're making inside of our card, let's make use of that card just below. Right here, we can call our first service card component right here as a self-closing tag. And now we can provide some parameters. In this case, we're going to provide a color. So let's do bg dash, and then in square brackets, that's going to be hash 295-2e3. Great. Below that, we're going to also give it a title, which is going to be security guaranteed. Like this. Let's also give it an icon by saying icon, and we're going to provide a component BS shield fill check with a font size is equal to 21 and class name is equal to text-white. And the last thing we can provide is going to be a subtitle. So we can say subtitle is equal to, and we can put some placeholder text, something like security is guaranteed. We always maintain privacy and maintain the quality of our products. Something like that should be fine. And that's going to be it for our service card. Now we know that our service card accepts a few properties. It accepts a color, title, icon, and subtitle, and all of these are props, so we need to destructure them right at the top, meaning we have to put them inside of curly braces. So now inside of this div, we can create one more div. This one is going to be for the icon, so let's give it a class name. And then we're going to make it dynamic like this, width -10, height -10, and that should be enough to already see it. So right inside of here, we can dynamically render the icon. As soon as we save that, you notice that something appeared here, but we cannot yet see it. So let's continue by providing more classes. Rounded-full, flex, justify-center, items-center, and then finally, let's give it a color like this. If we save that, you're gonna notice a blue dot right here, and that's not exactly how it should look like. Just to show you how a finished version should look like, I pulled up the finished site, and you can see right here, we need to have an icon, a white icon, on all of these circled backgrounds. So let's go back to our app and figure out why cannot we see our icon yet. And I have just noticed the reason. In here, I had icons instead of just icon. If we fix that, the icon is going to appear right here. And now below this icon div, we can have one more div. This div is going to have a class name equal to margin left 5, flex, flex-call, flex-1. And inside of there, we can have an h3 that's going to simply render out the title like this. And below that, we can have a paragraph that's going to simply render the subtitle. Of course, the entire text is dark right now, so let's fix it. Let's give it a class name equal to mt as in margin top -2, text-white, text-lg, and that's going to be it for our h1. For our padding, that's going to be text wide, text dash small, SM. And also on medium devices, we can say width is going to be 9 divided by 12, or 9 out of 12. Great. So now we have this great card. And you still might be wondering, why did we create this separate component if we're just going to render it right here? Well, the reason is, now that we extracted the code, we can reuse it as many times as possible. And that is the beauty of React. So now if I duplicate this 2 times, and if I change the BG color a bit, the second one is going to be 89845F8, like this. In here, we can say something like best exchange rates. The icon can be BI search alt. And then for the last one, we can change the color to be F84550. In here, we can say something like fastest transactions. And the icon is going to be RI hard to fill. If we now save this, you can immediately notice that we get 2 more of these cards instantly without any work needed. It just looks like we're missing the color for the second service card. So let's see. This is going to be just 894 like this, and we immediately get this nice purple color. Now, if we expand this a bit more, you'll see that this is looking great. We have our initial section, and with that, we have our services. Now that we have our services done, let's also check how our services look on mobile devices. So let's open Device Toolbar and go to Mobile. And as you can see, it looks like we're missing just one thing, and that is to make this into a column on mobile devices. To fix this, we can go back to the code and right here, say flex-column. There we go. And then say on medium devices, MD flex-row. So now for medium or higher, we're going to have a row, and on mobile devices, we're going to have a column. So it's looking great on mobile. And now if we go back, you're going to notice that this looks great on desktop as well. Now that that is done, let's focus on rendering out the list of our transactions. To do that, we can go back to our File Explorer and go to Transactions. Just to immediately have some transactions to work with, we can go to our utils, and down in the description, you'll find the dummy data file in here, and you can just paste it in here. This is going to be a list of 6 demo transactions, just so we immediately have some data that we can start rendering out on the screen. So you can just paste it inside of the utils once you find it down in the description. With that said, let's open up our transactions. And right here, we can import React as well as use context. And that's coming from React. Then we can import our transaction context because we're going to definitely use it later on once we want to fetch real transactions. So that's coming from /context and then transaction context. In here, I have a typo that's going to be just React. We also want to fetch .dummy data. So we can say import dummy data from /utils and then /dummy data. Inside of here, we can render a div. And that div is going to have a class name right here equal to flex width -full justify -center items -center 2xl px20. That's going to give it a padding x20 on extra large devices. Then we want to have the gradient -bg -transactions. If we save that, nothing is going to happen yet, but now we can add something inside of this div. Let's add a div that's going to have a class name equal to flex -col md p-12 py-12 and also px-4. That's going to provide it with some padding. And right here, we want to have a heading that says something like latest transactions. if we have our account connected. But if we don't have our account connected, in that case, we wanted to say something like connect your account to see the latest transactions. So to do that, we can pull some data using the context. Right here at the top, we can say const current account, and that's going to be equal to use context, and then we simply pass the context we want to fetch, and that is transaction context. So what we can say, open a dynamic block, and if there is a current account, in that case, we want to render. That's going to be an h3. It's going to have a class name equal to text-white, text-3xl, text-center, and margin y-2. Inside of there, we can simply say latest transactions. And now, if we don't have the account connected, then we can create the else part of our ternary and copy that same h3, paste it here, but now we're going to change it to say connect your account to see the latest changes. Great. Now we can remove these comments because we have our heading. Let's take a look. Right now, I can see connect your account to see the latest transactions. That's great. And I also have this button. This might be different for you because you might be already connected. I paused the recording of the video for some time, so MetaMask logged me out. This is going to happen from time to time. You just have to retype your password and you'll be straight back in. There we go. Now I'm going to reload the page. And as you can see, we can see latest transactions. That's great. One thing that we were also missing at the start was the address right here. We implemented the entire transaction sending process, but we never got into the point where we show the address of the connected account on this card, which is definitely a nice detail. So let's go back to our welcome right here. And remember, our current account is coming through the context. So now, just below, we can find where we're listing the address right here, and we can simply render the current account. There we go. As you can see, that is quite a long string. So to shorten it, we're going to create a new utility function inside of utils called shorten address.js. Inside of here, we can say export const shorten address, and that's going to be a function that accepts the address and then instantly returns a template string where we're going to take the address, slice it from the start, and take only the first 5 characters, or this is going to be 6 because it's starting from 0. Then we want to say ... We can copy this same part again, and instead of slicing from 0 to 5, we want to slice from address.length -4 all the way to the end. So we're taking the first 5 characters and then also showing the last 4. Now we can go back to welcome, and right here we can import our shorten address function, which is coming from /utils/shorten address. And the only thing we have to do is right here where we're rendering the current account, we can simply call the shorten address and paste the current account into it. That's going to give us this nice format, and that's the exact same thing that MetaMask does right here. Great. And the only reason we put it in utils is because we're going to use it in transactions as well. So right here, we can also immediately import shorten address from /utils/shorten address. Great. Now that we have this heading right here, we of course have to loop through the transactions. We can do that by providing a div right here. Let's fix this. That div is going to have a class name equal to flex-wrap, justify-center, items-center, and empty-10. There we go. And now inside of there, we can create a new dynamic block. We can render our dummy transactions for now. So we can simply say dummy data. And then we can call a dot reverse method on it to reverse it, because we want to start from the last to the first, or rather from the newest to the last. And then finally, we can also map over it by saying transaction, get the index, and then instantly return something. And that something is going to be a new component that we're going to create, which is called transaction card, like this, as a self-closing component. We can give it a key equal to I, and also right here, we can spread all of the properties that we get from transaction. That's going to take all of the properties from here and put it right into our transaction card as props. And these things are going to be ID, URL, message, timestamp, address from, amount, and address to. So inside of our transaction card, we'll be able to work with all of these values. Let's create our transaction card right here. Const transaction card is equal to a functional component. And as we said, we're going to get all of these values: address to, address from, timestamp, message, keyword, amount, and URL. And that has to be in curly braces because it has to be destructured. For now, let's simply return a string that's going to say transaction. There we go. And we should be able to see, there we go, 6 times transaction, 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 transaction. But now let's implement the JSX for each one of these transaction cards. Let's do that right here instead of this return. So let's return a div instead of a string. And that div is going to have a class name equal to bg dash square bracket and then hash 181918. Also margin dash 4, so m dash 4, flex, and then flex dash 1. Inside of here, we'll have to provide different widths for different device sizes. And we can do that in a new line, still inside of this class name string. First, on 2XL devices, we can set the min dash width, or just W, and then in square brackets, 450 pixels. Now we can duplicate that line and then set the max dash width equal to 500 pixels on 2XL devices. Now we can copy that, paste it below, and then on small devices, so SM, we want to set the minimum to be 270 pixels, and then let's do 300 for the maximum on small devices. We can also provide the flex dash call, p-3, rounded dash md, and finally hover shadow dash 2xl. Great. Now inside of there, we can have a div that's going to contain our content. So there's div. Let's give it a class name equal to flex, flex dash call, items dash center, w dash full, and mt dash 3. There we go. Now we have these gray rectangles. Now we can render out all of the data for our specific transaction. So let's do a div. We can give it a class name equal to display dash flex, justify dash start, width dash full, MB as in margin bottom dash 6, and padding dash 2. Now inside of that div, we can render 2 different anchor tags. So let's create an anchor tag right here. There we go. And this display flex was supposed to be just flex. So right here, we can create an anchor tag that's going to have an href equal to, and now bear with me, https://rupston.etherscan.io/address/ and then $, curly braces, address from, like this. Of course, we have to make it a dynamic template string like this. And also at the end, close it right here. Let's put this into a new line. This anchor tag is also going to have a target _ blank And it's also going to have a rel equal to no opener, no referrer. It is advisable to put this tag right here whenever you're using the target_blank. Inside of that anchor tag, we can create a paragraph that's going to have a class name equal to text-white, text-base. Let's fix this right here as well. And it's going to say from, and right here we can call the shorten address function and provide the address from into it. That way, we'll now have the address from for every single transaction. And when you click it, you'll be able to see that address and all of the transactions on the Robston test network on Etherscan. This is just providing that extra level of connectedness to the blockchain. Now, let's also duplicate this anchor tag. And just below, we can right here put the address to. This is also going to be address to, and we can say to. Now we have the from and also to. Below that anchor tag, we can create a paragraph that's going to have a class name equal to text-white, text-base. And right here, we can render the amount is equal to amount of Ethereum. There we go. It looks like we don't need this to be a flex container at all. We simply need to have a full width. So you can simply remove the flex and justify start from here. There we go. And now we have the from, the to, which are clickable, and also the amount of Ethereum being sent. Finally, if there is a message with that specific transaction, so message and end, in that case, we can render a new React fragment that's going to have a break tag right here to divide it a bit. And it's going to have a paragraph that's going to have a class name equal to text-white, text-base, and we can simply say message is equal to message. There we go. Since these are our demo transactions, they don't have a message, but all of the ones sent through our own network will have a message property. Great. And before actually rendering out the image, which is going to go right here, we can render the timestamp. The timestamp is going to be a div that's going to have a class name equal to bg-black, p-3, px-5, w-max, rounded-3xl, minus -mt-5, and shadow-2xl. Right now, that's not really noticeable, but we have a small rectangle right here, and we can provide a paragraph right inside of that div right here. That p tag is going to have a class name equal to text dash, and then in square brackets, hash 37c 7da, and it's going to have font dash bold. In there, we can simply render the timestamp. Right now, we got an error because at the top, I misspelled the timestamp. So if we spell it correctly, you can see it right here. Of course, this is not yet aligning properly because we don't yet have a GIF corresponding to our keyword that we're mentioning right here. And we can also fix this keyword right here. I noticed that I misspelled it. So let's search for keyword. And let's remove this O, which is a typo right here. That's a lot better. To fetch our GIFs, we're going to use developers.giphy.com, the world's most popular GIF platform. So let's create a new account right here. You can go to sign up. You'll have to enter your details, and then I'll see you right in their dashboard. And there we go. If you successfully created your account, you should be on your own account page. So now let's explore the Giphy platform by going to Giphy. And we're not interested in these GIFs right here. We want to go to developers.giphy.com. Now you can click read the docs right here or create the account, whatever it says. And then at the bottom left, if you're successfully logged in, you can click create an app. In this case, we're going to choose a Giphy API because we don't need any GIF creation tools. We simply need to be able to query over the existing GIFs. and click next step. We can enter our app's name, which is going to be crypt in my case. And how will we use our Giphy key? That's going to be to query different GIFs. And let's click right here and create an app. There we go. You just got your API key, and that's all that we need. We can copy it, go back to our application, and we're going to create a new .env file. So right inside of our client folder, not inside of the source, right here, right click and click new file and call it .env. Instead of React underscore app, in this case, we're going to use Vite underscore Giphy underscore API is equal to, and then you can paste your API key right inside of here. Now you can open up the terminal, press Ctrl C to stop it, and then just npm run dev again to run it, and then you'll have access to your Giphy API environment variable. Now we were on our transactions page right here, where we had everything besides our GIF image. So what do we have to do to fetch this image? Well, we're going to create a custom hook. So right here, we can create a new folder in the source folder called hooks. And right inside of there, we can create a new use fetch.jsx hook. Inside of here, we'll write the logic for fetching the GIF based on a specific keyword. But since this is not related to the application, to fetch the GIF, we can import use effect and use state, and that's coming from React. We can also say const API underscore key is equal to import .meta .env .vite underscore Giphy underscore API. This is going to give us access to that API key variable. Then we can create a new use fetch hook, a custom hook to be more precise. Right here, we can create a new use state field, which is going to be the GIF URL. And at the start, it's going to be set to an empty string. Then we can create a const fetch GIFs function. That's going to be an async function. And it's going to have a try and catch block. Inside of here, we can try getting the response from the Giphy API by saying await fetch, and then in here we have to enter the API we want to fetch from. And to find that API, we can go into documentation right here, and we want to fetch specific APIs. So let's go to quick start guide, and let's try to find different endpoints. So right here, GIF and sticker endpoints, search endpoint, and you can see that it is api.giphy.com, v1, GIFs, and then search. This is exactly what we need. So let's copy this, paste it into this string right here, but we have to provide https:// at the start. And then we have to provide some parameters, things like Q as in query and API key. So at the end, let's simply say question mark to provide parameters, API underscore key is equal to, and then $ curly braces. We have to turn this into a template string to be able to use logic inside of our string. Right here, we can render our API underscore key, and then we're going to say end Q is equal to, that's going to be $ curly braces, keyword dot split, and we want to split it by space because someone might actually type a few words into our input field right here. And how are we going to search for GIFs then? So we're going to first split our string with spaces like this, and then we're going to join it right back by saying join, and then we don't pass a space right here. That way, we'll just have one word without spaces in our keyword at all times. And finally, at the end, we can say and limit is equal to 1, because we need to be able to find just one GIF. Now that we have our query, we can destructure the data from the response by saying const in curly braces data is equal to await response.json. And finally, we want to set the state of our GIF. So set GIF URL is going to be equal to data 0 question mark dot images question mark dot downsized underscore medium dot URL. And let's also put a question mark dot right here. And to handle the catch, we can go to our utils, dummy data. We can copy one demo URL from these, go back and simply say set GIF URL to be equal to a string of that specific GIF. That's going to be a random GIF. So if a new GIF isn't found, we can just use a demo one. And finally, when are we calling this fetchGIF function? Well, we'll call it just below inside of the use effect. Our use effect is going to happen whenever the keyword changes. So right here, we're going to pass the keyword, and the keyword is going to be coming through props to our use fetch function or use fetch custom hook. So right here, we can say keyword, and whenever the keyword changes, we can simply say if there is a keyword. In that case, we want to call fetch GIFs function. And the last and only thing that our use fetch function is going to do is it's going to return a GIF URL. And finally, we have to export default use fetch. Again, just make sure that this specific query for fetching GIFs is written correctly, and also that you don't have any mistakes in the logic right here. If something doesn't seem to be working, in that case, you can check the GitHub repository and find the use fetch.jsx file and compare it with your own. So now that we have our use fetch function, we can go back. We can import, that's going to be use fetch from /hooks / use fetch. And now right inside of here, inside of our transaction card, we can say const GIF URL is equal to use fetch, and we're going to pass in an object that's going to contain the keyword. Great. So where are we going to render that image? That's going to be right here. We can simply say image as a self-closing tag, and then we're going to provide a source, which is going to be just a GIF URL or URL. This is going to be for our demo images. We can give it an alt, which is going to say GIF. And then finally, we can give it a class name, w-full, h-64, 2xl. Then we're going to make it height 96, rounded-medium, shadow-lg, and object-cover. Now, if we save that, you can see right here, something seems to be broken. It always has to be broken first, only so that it can work later. So let's see what are we missing. I'm going to open up our console, reload the page. And right now, we shouldn't even be fetching real GIFs because we're rendering just the dummy data. So in here, we should have or and not just one single straight line. As soon as we add or, our GIFs are right here. There we go. So now we have the 6 of our dummy transactions. And looks like the timestamp is going into the image, which shouldn't really be the case. So let's see. The image and this div with a timestamp should be outside with the entirety of the other content. If we save that, now you'll see that the timestamp goes nicely over the image. This is looking great. But of course, these are just dummy transactions. These are not the real transactions that we sent through our network, and they're not read from the blockchain. Anybody could have done this, right? This is not a Web 3.0 application. So right now, let's just finish up our site with a footer, which is going to be incredibly quick. And then we're going to replace these transactions to show the real transactions that are sent through our Ethereum blockchain. To implement the code for our footer, we can go, of course, to our footer component. And right here, the only thing we're going to import is going to be the logo right here. And that's coming from /images / and then that's going to be logo.png. Everything else we're going to code straight away. So right inside of here, we can create a div, and this div is going to have a class name right here, which is going to be equal to width dash full flex md justify dash center justify dash between items dash center flex dash call padding dash 4 gradient dash bg dash footer. There we go. Now we have our entire page fill in these gradients. Inside of that div, we're going to have one more div. And this div is going to have a class name equal to width dash full flex on small devices flex dash row and usually flex dash column justify dash between items dash center and margin y dash 4. Finally, we're going to create a div that's going to contain our image. So right here, we can create an image. That image is going to have the source equal to logo, alt is going to be logo, and class name is going to be width dash 32. If we save that, you can see the crypt logo right here. Let's provide some class names to the outer div. Some things like flex, flex dash, and then 0.5. This is going to take just half of the space. Then justify dash center and items dash center. There we go. Now we positioned it right here. And below that, we want to have one more div. This div is going to have a class name equal to flex, flex dash 1, justify dash evenly, items dash center, flex dash wrap, on small devices, mt dash 0, usually mt dash 5, and width dash full. Now inside of there, we can put our links. And these links are just going to be different paragraphs. Let's do something like market, and then let's give it a class name equal to text dash white, text dash base, text dash center, mx dash 2, and cursor dash pointer. There we go. And now we're going to duplicate this 4 times, or rather 3 more times, and change this to say exchange, then something like tutorials, and finally wallets. And there we go. We have our 4 links with this crypt logo right here. We can also do something more for our footer. So let's create one more div, but make sure to do it below these 2 divs. And right here, we can give this div a class name equal to flex, justify dash center, items dash center, flex dash call, mt dash 5. Inside of there, we can create a paragraph. That paragraph is going to have a class name equal to text dash white, text dash small, and text dash center. Inside of there, we can say, come join us. And then just below that, we can enter our email, something like info@cryptomastery.com. And there we go. Come join us is right inside of here. And that is one great thing about custom emails and custom domain names. If you purchase the Hostinger's shared hosting plan, you're gonna get plenty of email addresses completely for free. And then you can create your addresses such as info@ and then yourdomain.com. If you're building a serious site or a portfolio website, it definitely makes sense to have this, as it provides an extra level of authenticity to your site. Someone is much more likely to purchase something or use your site if you have a custom domain like cryptomastery.com. So if you haven't yet purchased the Hostinger plan, you can still do that by the end of this video. Now let's continue and finish up our footer by creating a self-closing div tag with a class name equal to sm:\w dash and then in square brackets 90%, like this, width dash full, height dash in square brackets 0.25 pixels, and then bg dash gray dash 400 mt dash 5. This is going to create this nice line right here. And finally, we have to have the last div of our footer. So let's create that div. This div is also going to have a class name, and it's also going to start with small width 90%, so we can copy that, width dash full, flex, justify dash between, items dash center, and empty dash 3. Now inside of there, we can copy this paragraph where we say come join us, paste it here, and we're gonna say at Crypto Mastery 2022, and we can duplicate that one more time, and we're gonna use that famous line, all rights reserved. There we go. This is looking so much better. This just concluded the entire design of our website, starting from the nice welcome page with the form to send Ethereum across blockchain, nice header at the top, the services page, latest transactions page, and finally the footer. Now is the time that we get back to some blockchain work and actually retrieve the list of all transactions that were sent across our network. Let's do that right away. To get our transactions, we're going to go into context and then transaction context. Now we can go just below our check if wallet is connected function. And right here, we can create one new function, which is called const check if transactions exist. And that's going to be another async function like this. It's going to have a try and catch block. And in here, we also want to get that Ethereum contract. So we can copy that line from here. Const transaction contract is equal to get Ethereum contract. Paste it here. And then we want to get the transaction count, which we are already doing here. So we can copy that from here. That happens once we're sending the transaction. So we get the transaction contract, and then we get the number of transactions. The only thing that this function is going to do is going to be window.localStorage.setItem. And in here, we want to set the transaction count to be equal to transaction count. That's going to be it. And we can copy the error from here because it's going to be the same. Now we can call this function just below calling our check if wallet is connected right here. And that's going to be it. That's essentially just going to set up the current number of transactions so that for every new transaction, we know which one is it. And now finally, the part you've been all waiting for, we can create a new function just below our handle change, which is on top, called const get all transactions. That's another async function that's going to have a try and catch block inside of it. We also have to check if people have MetaMask installed. So we can say if no Ethereum object, then return please install MetaMask. And the only thing we have to do is say const available transactions is await transaction contract and then dot get all transactions. This is a special function we created on our smart contract that's going to return all of the transactions. But we first have to get this transaction contract, and to do that, we can simply copy this line, const transaction contract is equal to get Ethereum contract. Let's paste it here, and that's going to be it. Now we can console log all available transactions right here. And also for the error, let's simply console.log that error. There we go. We can reload the page. And we have to call get all transactions somewhere. But of course, we won't be able to see this console log because this function is never called. So in the check if wallet is connected, right here, we want to get all available transactions. Great. Now we can reload the page, go to console. In the info, right here, we can see an array with one element. If I'm not mistaken, we only made one test transaction, and this is it. You can see it has keys from 0 to 5, and also it has some object properties, such as the amount, keyword, message, receiver, sender, and timestamp. But this is in a bit of a weird format here, with the numbers as keys and then the real keys. So let's create a new structured transaction. We can do that by saying const structured transactions is going to be equal to available transactions dot map, and then we're going to get each transaction, and we simply want to instantly return an object. You do that by putting parentheses and then inside of them an object sign. So what do we want to do? We want to have the address to property, which is going to be equal to transaction.receiver. Then we want to have the address from property, which is going to be equal to transaction.sender. Then we want to have a timestamp, which is going to be equal to new date, transaction.timestamp, and then dot to number times 1000. And finally, dot to locale string. This is going to give us that nice time and date representation. The thing I'm referring to is this format right here. Then we're going to have a comma. Then we need a message, which is simply going to be transaction.message. We need to have a keyword, which is going to be transaction.keyword. And finally, the amount is going to be parse int transaction.amount._hex. And then we're going to multiply that by 10 to the power of 18. Because if you think about it, we already discussed it, that all values are written in hexadecimal, and not only hexadecimal Ethereum, but hexadecimal Gwei, which is the subunit of Ethereum. So to get Ethereum, we have to multiply it by extremely large 10 to the power of 18. That is going to give us the real Ethereum amount. Now that we have our, I have a typo here, structured transactions, we can simply set them to the state by saying set transactions, and that's going to be structured transactions. Great. And let's also console log them so we can see if everything is right. If we go back, reload the page, we should be able to see that one transaction, set transactions, is not defined. Let's see. That's because we don't yet have the use state hook for our transactions. So we can create transactions and set transactions, and at the start, that's going to be set to an empty array. If we save that and reload the page, you can now see that we have an array with one object, and that is a nicely formatted transaction. But we have few issues. One is with the amount, and the other one is with the timestamp. The amount seems too big, and the timestamp is an invalid date. So let's fix those right away. For our timestamp, we need to say new date, transaction.timestamp.toNumber, but this here is supposed to be a function. So if we now save this and reload the page, now our timestamp is going to be correct. It is right here. And for the amount, we have to say parse int transaction.amount._hex, and then this here is not going to be times, is going to be divided by 10 to the power of 18. If we now save this, reload, you can see that the amount is 0.0005 Ethereum. Great. So now we have the list of our transactions, and we can go back to our transactions page. And instead of rendering dummy data, we no longer need that. We can simply render real transactions right here that we're going to get from the context. So transactions, we render those transactions right here. But don't forget, we have to pass them right here into the context. So value, we're going to pass the transactions as well as the isLoading state, because we have to use that as well. Now we can reload the page. Before sending another test transaction, let's go to our welcome page. And I remembered that we forgot to implement the loading, because if you remember, right now we have this to false to never show a loader, but at the top we can simply get the isLoading from context right now, because we're passing it through the context. So if we scroll down, now we can simply say if isLoading, render out the loader, else render out a send now button. So now if we scroll down, we should be able to see our test transaction. And there it is from our own account. And we can verify that if we go to MetaMask 0x53c, and there we go, it starts with 0x53c, ends with 73AA, and that seems correct. And we indeed sent 0.005 Ethereum, and the message was test, and here is a GIF representing our keyword of test as well. Great. Now, to verify that everything absolutely works, let's send a few more transactions. I'm going to again go to MetaMask, Accounts, Account 2, click Dismiss right here, and copy the address. I'm going to paste it right here. Let's send another 0.005, or let's be generous and send a bit more, 0.001. The GIF can in this case be hello, and the message can be hello from account 1. And let's go ahead and click send now. We get that MetaMask notification. I'm going to click confirm, and we get that contract interaction, and I'm again going to press confirm. The loading now works, and this is looking phenomenal. In about 10 to 30 seconds, the transaction should go through, and we should be able to see it just below. And there we go, the loading stopped. I'm gonna reload the page, and now if we scroll down, as you can see, we have two transactions right here. This one is saying hello as we specified, and the message hello from account 1 is here, 0.001 Ethereum. So that's looking good as well. So there we go. That's it. We have our two transactions, and just for good measure, let's try to send one more. I'm again going to paste the same address of the account 2. Let's do something incredibly big this time. Let's see how much do we have in our account. 0.14. So let's do 0.1, the 10th of 1 Ethereum. And in this case, instead of hello, let's try with hi. And the message can be, here's a gift for you. And let's click send. Again, we'll have to verify it through our MetaMask, confirm, and then contract interaction, confirm as well. We have that nice loading, and as soon as it's done, we can reload the page, or we can also go to our transaction context right here, and we also increment the transaction number. We can do window.reload. That's going to reload the page as soon as the transaction is done. And there we go. Hi there, here's a gift for you. And let's check if our Ethereum wallet 2 actually received the Ethereum. And there it is, 0.1015. That is it. As I've said, the other account could have been on the other part of the world. And in just about 20 to 30 seconds, you can send any amount of money through the blockchain network. Isn't that crazy? With that said, we're slowly coming to the end of this video. This has been a phenomenal project, and I haven't been this excited for a video in quite some time now. And for the end, I'm going to teach you how to deploy this project to Hostinger. That way, we're gonna have a custom domain, and you can also create as many custom emails as you want. With that said, let's go ahead and deploy this project together right away. And we are back on our Hostinger's dashboard. I already purchased the domain cryptomastery.com. If you purchased yours, it's going to be right here as well. If you haven't, you can do that right away. Again, the link is down in the description. If you haven't yet connected the domain to your setup, the setup is going to be right here. But if you already connected it, it's going to be right here under Premium Shared Hosting, and then your domain name right here. In this case, we're going to go to Manage. You can scroll all the way down and go to the File Manager. You can click this new File Manager right here. That's going to lead you to your H panel. You can go into the public_HTML document. And right now, we just have this default.php, which you can delete right here. And press yes. Now we have to put our build folder right into here. And we can create our build folder by going back to our application. We can close all of our files by holding Control and then pressing W, collapse our file tree, and then open up the terminal by going to View and then Terminal. We can stop it from running by pressing Control C and then Y. We can clear it, and while still staying in the client, we can run npm run build. This is going to create an optimized version ready for production. And there we go. With Vite, it's incredibly quick. We have our deployed version under dist. So you can right-click it and then click Reveal in File Explorer. Once you've done that, you can simply drag and drop only the dist folder right into here. Once you open this in File Explorer, it should look something like this, and then you can enter the dist folder. The only thing you have to do is drag and drop the assets and the index.html right into here. That's going to take just a moment, and your files are going to be right here right away. And that's about it. If we now go back to our hosting panel, scroll to the top, and click your domain name right here, you should be able to see that it's going to load out instantly. But there's one really important thing left to do, and that is to enable the SSL certificate, because our site is currently not secure. So we can go back, we can search for SSL right here, click it, and then Hostinger just makes it so easy. The only thing we have to do is say install SSL. SSL is being installed as we speak, and this process usually takes just about a minute. I was wrong. It actually took just about 5 seconds. I reloaded the page, and there it was. So now if we go back in here, and if we reload the page, as you can notice, we have this lock right here, which means that connection is secure. And again, especially with cryptocurrency applications, having a custom domain name, SSL certificate, fast load times, and a custom email definitely comes in handy, because there are a lot of cryptocurrency related scams and you need your page to be secure and reliable. With that said, let's see if our blockchain transactions are going to work on our deployed site as well. As you can see, we haven't yet connected our MetaMask wallet to our deployed site, and that's why we have just these 3 dots right here. So let's click Connect Wallet. A notification is going to appear, and in this case, let's connect the account number 2. Next, and connect. Just like that, our address appeared right here. We can open our MetaMask, go to account number 1, dismiss, copy the account address, paste it here. Let's send 0.1 back. Let's do something like blockchain and say, here, take your Ethereum back, and a smiley face. And let's press send now. Sending Ethereum, confirm, and then contract interaction, confirm as well. The loading is happening. Let's go to account 1 and wait for the transaction to happen. And there we go. In about 30 seconds, the transaction went through, and we now have 0.14 Ethereum on our account 1 on Robston Test Network. Let's reload the page, scroll down, and there we go. Our blockchain GIF stored on the blockchain forever. Looks like Ethereum is climbing to fight the Bitcoin King. And all of this is happening on our new deployed domain, which means that absolutely everyone can create their own MetaMask account, wallet, and send Ethereum through the application that you created and deployed. Phenomenal job. Thank you so much for watching this video. It's been a crazy experience, at least for me, connecting a React application to the blockchain. It's a revolutionary technology, and it's going to definitely take the world by storm in the upcoming months or years. So, if you'd like to see more Web 3.0 videos, just let me know in the comments, like this video, and share it. With that said, thank you so much for watching, and have a wonderful day.